this masterclass, I'm going to make sure I explain every single concept that a modern data engineer has to know about Airflow. When I say that, I don't mean I'm just going to dump all the theory onto you. I will make sure I demonstrate everything I talk. And on top of that, I will record myself writing the code by explaining it line by line so you can follow along. And here's the best part. For every file, code, or website I use in this masterclass, I will provide the link down below in the description so you don't have to search that anywhere else. You can just grab them and work right on. Finally, if you like the video, don't forget to subscribe and share to your friends who want to learn Airflow. Let's dive in. Welcome to the Airflow Masterclass. Before getting into the topic, let me tell you how I structured this masterclass. All right, I created a few slides for a few of the topics where necessary, and few of them I will draw the architecture to explain, and for the other I will demonstrate them too if it is necessary. Okay, the first question: why did I pick Airflow out of the other orchestration tools out there? The reason is there are a lot of orchestration tools, by the way. There are a lot easier orchestration tools than Airflow. For instance, let's take Azure Data Factory. It is so easy, just drag and drop. You just drag and drop the tasks and you relate these tasks one to another. It is so easier than Airflow. But it is so hard when you want to copy that workflow that you created in that orchestrator tool into a different environment. Whereas in Airflow, it is so easy. By the way, you don't drag and drop in Airflow. You have to, you just need basic Python knowledge to write this, orchestrate this workflow in Airflow. So you just need to have a basic coding language, coding knowledge for that. The Python knowledge. So you write these tasks, you customize them by your own. So when you want to copy this workflow to another different environment, you just need to copy, paste the code. That's it. It is that simple. And it's also so efficient when you implement CI/CD to it. It is so easier. Whereas the drag and drop ones, it is so hard. But the only advantage with the drag and drop orchestrators is those orchestrators are so easy for the beginners. It is so beginner friendly. That is why Data Factory is easier than Airflow. But Airflow is the top orchestrator among the rest right now, and it is the modern data engineering tool. So that's why I chosen Airflow for this masterclass. Now, what is Airflow? Airflow is a workflow orchestrator. To be clear, let's say you're working for a company. When you work for a company, you don't just run one or two scripts a day, right? You run a lot of scripts, and most of the scripts are repetitive. You run the same scripts every single day, or every Monday, or every weekdays, and you don't want to manually run the scripts. It just eats your time. So instead, we can just automate this script running using Airflow. So you can just schedule when to run these scripts. You can just design a workflow which has a lot of tasks in it, which means a lot of script runs, different script runs, and you can also implement dependencies between these tasks. What do I mean when I say dependencies between tasks? Let's say you have task 1 and task 2, and you want task 2 to be run only when task 1 is completely executed and successful. If task 1 fails or it is still running, task 2 won't start executing. So you can craft these type of dependencies between tasks using Airflow. You create a DAG and then you just give it to Airflow, and Airflow handles the scheduling. It runs these set of tasks at scheduled time. That's how Airflow works. Now, I talked about workflow. When we define this workflow in Airflow, we define them using Python, right? So when we define this workflow, a set of tasks in Airflow, we call that workflow that is defined as DAG, D-A-G, which stands for Direct Acyclic Graph. So we call these workflows which are defined in Airflow as DAG. That is what DAG file means. On top of that, Airflow also offers monitoring, where we can monitor the logs, if the task is successful or it is failed, the reason for the failure, and we can also trigger alerts wherever we want. That is how Airflow works. That is what Airflow is. What Airflow is not. Firstly, Airflow is not an ETL tool. If you don't know about ETL, ETL is extract. ETL stands for extract, transform, load. Basically, this is what every data engineer do. They extract the data, transform the data, load the data. So Airflow is not an ETL tool. Well, it is part of the process, but it is not an ETL tool. It don't help you extract the data or transform the data or load the data. It just automates the flow, automates the workflow happen between ETL. That's it. And the next, it is not a data processing engine. Like I said, it don't do any of that process. It don't extract or transform, or it is not a data processor. It is just an orchestrator which automates the workflow. And it is not a real-time streaming. It is not for real-time streaming. We can schedule the tasks, or we can use sensors to trigger the DAG, which is the workflow, whenever we want, but it is not real time. It is scheduled or can be triggered. That's it. It is not real time. It's not real time streaming. And then it is not a replacement for Spark, SQL, or Python. You can orchestrate that workflow using Python, but these scripts, the SQL scripts or Python scripts or Spark, the PySpark scripts, should be still written by yourself. And yeah, it is not a replacement for any of those. It is one of those tools where we can just automate the flow. When to run these SQL script, or when to run this PySpark job, or when to run that Python code. So we just say when to run. When to run and how to run. That's it. Now, when not to use Airflow. There are a few times when you don't want to use Airflow. One of them is, like I said, in real-time streaming, when you want the results to be real-time, like a stream, you don't want to use Airflow. Well, you can schedule it, but it still cannot make it real-time. And if you only have one task to be executed, you don't want to use Airflow because it is heavy work for just one task. You just need to set up a lot of infrastructure for this. So it is not worth it. So when you have one single task, Airflow is not the way to go. Yes, and you have to remember, like I said, Airflow doesn't do anything. It just triggers that process. If you're, let's say, if you're processing the data using Python, it don't process. It is not responsible for the data processing. It is done by Python. Just triggers that process, and whatever the tool you use, it can be Python or SQL or PySpark, that is what responsible for that data processing. You script it and say Airflow, okay, I have this script, just trigger it at this particular time, and Airflow does that for you, nothing else. Now, building blocks of Airflow. It includes tags, tasks, and operators. We already talked about that, but in this topic, we're going to dive into that. So what is a tag? Like we already talked about it. Tag defines what should run and in what order it should run. Tag is a Python object and it is a static definition. When I say static definition, when we define a tag, right? It is not a task. We define a tag, it is not a script. It is a definition of which order the task should run. So when we define a tag, it will not be changed dynamically with any of the influence of from any script. So it is static definition that we just define. Okay, we got the tag now. Now, what is a task? Let's say tag is a blueprint, right? DAG is a blueprint of the plan to execute. And task is one node, it's just a part of the blueprint. There are a lot of nodes that are connected to each other, nodes which are tasks. So they are all connected, and task is one of the part. That's it. A single unit of work. Task is just a single unit of work. Task is like a responsibility to be done. And one more thing we have to know about task is, if there are multiple tasks in one single DAG, the data from one task cannot be accessed by the other task without using any component. We have to use a component to access the data from this task in another task. We call it XComs. We'll talk about it later, but yes, without any of the component, we cannot access data from one task to another task. They are all independent. Then we have operator. Like I said, Airflow or a DAG is not a tool to run the script. You don't run the script by itself. It uses a tool. It can be Python or SQL or PySpark. It uses a tool to run that script. So to define that tool that we're going to use to run the script, we use operator. We define how a task, like it says here, so it defines how a task does work. It is a Python class. So if you want to run a Python script, a small block of Python code, you have to import Python operator first, and then using that operator, in that operator you write the script that you have to run. If you want to run a bash command, you import bash operator, and then you write the bash command inside the operator, so it recognizes it, and bash. So if it is Python, Python will run it, not Airflow. So it is not a I don't know how to say it. So it is not a tool to run the code. It makes other tools to run the code. You can import that. When I say that, I don't mean you have to install Python separately. You can just install Airflow, and Airflow comes with pre-installed Python and the other stuff. You don't need to install any of that. But still, Airflow doesn't run that task. You have to know about that. Okay, that is done. Talk about dependencies, right? When you have multiple tasks, the dependency tells the relation between these tasks. And now I'm going to show you how that actually works. All right. So let's say you create a DAG with 3 tasks. Okay. So let's say this block, let's name this block as DAG. Which stands for direct acyclic graph. Right. We have that. So that is the blueprint. Now in the blueprint, we define 3 tasks and also their dependencies. So let's name our first task as task A. So that is our first task, and our second task as task B. And for our third task, I'm not going to connect that node directly to the root of the DAG, but I'm going to connect that node to task B. So that is task C. Now we have 3 tasks in this DAG, but task A and task B is connected directly to the root of the DAG, whereas task C is dependent on task B. Now this whole thing is called DAG, and this particular block is called task. So these particular blocks are called tasks. They have the responsibilities to be done. But what you have to know is task A and task B are independent. So whenever a DAG run executes, whenever a DAG run occurs, these two tasks start executing parallelly. You don't wait for anything, right? When the DAG is scheduled, these tasks will start executing. Whereas task C will not immediately start executing. It waits, task C wait for task B to complete the execution. And only when task B is completed, the execution is completed, only then task C will execute. If task B fails, let's say it fails, task C will never be executed if it is dependent on task B. That's how the dependencies work. When you have multiple tasks, you can define the dependencies between these tasks. So you can say in what order these tasks should run. That will follow the tasks, the order, and you can run the task parallelly, like task A and task B, and yeah, that's how the DAG works. We know the structure of the DAG and what DAG has and how the dependencies work, right? Because I already show you how the dependencies work. We define the task flow, yeah, what tasks wait for the other tasks and what doesn't. So I show you the dependencies and how DAG works. But now, after you create the DAG, after you write the whole DAG and define the DAG, what is the life cycle after it is defined? So we're going to talk about the DAG life cycle basically. So when you create a DAG, when you initialize Airflow on your PC or any of the machine, it creates a folder named DAG. It also creates multiple other folders, other volumes, which includes logs, one for the logs and plugins. There is this one called DAG, where you place your DAG files. You write your DAG code and then save the file. And this file will be saved in this DAGs folder. Only then Airflow can scan the DAG file. So once the file is in the DAGs folder, Airflow usually scans that DAGs folder often. So it scans it and it picks that DAG file up, the DAG file we created. And by the way, this DAG file will be in .py format because we write that in Python script. So the file will be, let's say, abc.py. So it's a Python file. Airflow scans that DAGs folder a lot of, often. So when it finds that file, it picks it up. Before it executes the DAG by itself, it won't even show you on the UI. It first runs it. It first runs it. And if there is any broken task or broken logic or syntax errors, it will pop an error, or sometimes it won't even show you what happened. It will show you. Yeah. Whenever it has a broken logic or broken syntax, it just pops an error saying it shows the error too. You have to fix it. So at that stage, it just passes that DAG file. If there is a broken flow, just shows you have to fix it. After it is fixed, it takes that DAG file and reads the blueprint. It passes it. Actually, passing means it's just segregating all the tasks the DAG has. So it passes it, and then this passed tasks will then go to scheduler. So there is so the DAG will first get passed, and then it goes to scheduler, and then it executes. So in the scheduler, what happens in the scheduler is scheduler decides when the DAG run has to be executed. So based on the schedule interval or the dependency, you will schedule the DAG runs. and when the schedule interval triggers or meets the criteria, then the DAG will get executed. And yes, and these DAG runs, once the DAG run exists, tasks are queued and executed according to the dependencies they are structured in. That's how the executor works. And these all things have a lot of components between these process, and I will talk about the components in Airflow in the later slides. But now this is the life cycle. So first it gets parsed and then scheduled and then executed. That's it. That is it about the DAG lifecycle. Now let's head to the next topic. Let me just close the slideshow. By the way, if I'm going to show you this slide, the DAG lifecycle that I prepared, but that's fine. Okay, moving on. Our next topic is Airflow architecture. You have to know about the architecture, right? But yeah, we are almost done with the theoretical part. We're going to head to the demonstration sooner. But yeah, we have to know about the architecture. Talking about Airflow architecture, Airflow is not just a single program that you can install just like an application. This is a combined, this is a combination of components that you need to form, to run Airflow. So if you want to install Airflow on your PC, there are a lot of ways to install it. But in this video, I'm going to show you how we can install Airflow using Docker containers. And when we install Airflow, like any other application or program, we can't just install Airflow directly. We have to install the components. And in these components, there are a few components that are mandatory, that are required to run Airflow, and there are few components that are not important, that are not mandatory, but they're optional. You can use them according to the requirement. And I'm going to show you the architecture here. So when we install it, we have to install all those components, and these components combined make our Airflow work. Talking about the components, let's talk about the first component, metadata database. First component, metadata database. This is the name, just like the name says, it is a database that is like a personal database that Airflow manages, where it stores all the logs, all the data that it has, like the DAG state, the task state, the run history, and schedules, and the retries. But I don't think I told you this. So whenever a task fails in Airflow, in the DAG run, so it retries. And the amount of times it retries will be defined when we define the DAG. We define it. We define the amount of retries a task will go through. So all these retries and the task, the logs, I mean everything. The task runs, DAG state, task state, everything will be stored in metadata database. So this is just like a database. And on top of this, I just copy that. This there is scheduler. Slash. Scheduler is like a brain. So whenever DAG gets into the DAG's folder, scheduler will pass the DAG file and schedules it accordingly and stores the, and like I said, it writes a task runs to the metadata database. It decides when the DAG should be run. And yeah, basically without scheduler, Airflow cannot run. So scheduler is mandatory component and metadata is also mandatory component. Moving on to the next component. The next component we have is executor. To resize this blocks, I think. That's fine. Now, I spelled it wrong. Okay. Now, executor decides how these tasks are run. The scheduler passes it and decides when this DAG run should be scheduled, right? Now, executor decides how these tasks in the DAG should be run, should run. And there are a lot of types of executors, which includes local executor, Celery executor, Kubernetes executor, and there is also sequential executor. There are 4 types of executors, and the four of those executors are different. We'll dive deep into those executor topic in the later in the future. But for now, yeah, you have to know about that. So executor is not a business logic. It does not run any logic. It just decides how these tasks should be run. And then we have web server. And then we have a web server. For now, these are the mandatory components we need to run the Airflow. We need metadata database, we need executor, we need scheduler. These are the only mandatory components. Apart from these, any component is just optional, whereas web server is the best practice. Web server is just like, let me first connect this. Basically, web server is just a UI, just to see or just to visualize by reading from the metadata database. It just reads, that's it. So it doesn't do any core executions, or it doesn't participate in any core of the DAG runs. It just shows you the metadata data, the logs in the metadata database. It shows DAGs, runs, logs, retries, but it won't contribute in the DAG execution. It just shows you the logs. And one more thing about this is web server, it can also be called as API. I think it is API server now. Okay. So these three are the main, these three are the mandatory components that we need to run Airflow. And this is not mandatory, this is just, optional. And the next component is workers. Let me just copy this block. For this, let me just decrease the size. this block goes here, say here. Okay, talking about workers, until now, it is all about the relations. Yeah, so until now, all these components is about the relation and the coordination. But these components, the workers, are just pure task execution. Depending on the executor, these components are required. So they're only required for salary executor, and but for the rest of the executors, we don't need them. So they are optional. These workers let the Airflow to run flawlessly with heavy loads of work. So let's say for our personal use, it is not so differable, but for in industrial uh, scenario, there is a lot of load that put on the system, right? So we cannot hold that load. We cannot process that humongous amount of data with that kind of load in just one PC. We have to split that work separately to different uh, machines. For that, we define those machines, the separate machines, as workers, and then we use those machines for one process. So we just distribute the load across the machines using workers. And these workers are only used in celery executor. Like I said, there are a lot of types of executors, and celery executor is one of them, where we use workers to distribute the load, where we run the tasks. Okay, we have the worker. When I say we distribute the load in celery executor alone, I don't mean we only use multiple machines just in celery executor. Even in the regular executors without workers, we can even run scheduler in one machine and executor in one machine and metadata database in another machine. So we can just split them, these components, to different machines to spread the load. We don't actually have to run these components all in one single machine. We can spread these components to multiple machines, to distribute the load. It's not necessarily have to be a worker and executor relation to split these workload. So this is the basic architecture, but there is another component that got recently added into Airflow, but it is not, it wasn't in the legacy Airflow in the old Airflow versions, but recently they also added a component next to here called DAG processor. Okay, so they add this component called DAG processor. So it splits the load with the scheduler, just the scheduler itself. So it's the task, the responsibility of this component, the DAG processor, is to pass the incoming DAG file. It is to to pass the DAG file and separate these tasks according to their defined what to say relation between the tasks. So it just passes the DAG file. The whole purpose of DAG process is to pull the DAG file from the DAGs folder and pass it. That's it. Before this, before the DAG processor is in the picture, in the version, scheduler used to do the whole process, taking the DAG file from the DAG folder and processing it, which includes passing the DAG file and then scheduling it and writing the logs of that DAG runs into the metadata database. Everything used to be done using scheduler alone, but they introduced DAG processor to split the load evenly to the machines. That is relatively new, but yeah, that is also optional. You don't have to define this component. You just need these three components. These three are the main required components to run Airflow, and the rest of them are optional. I'm going to give you this PPT file so you can just refer anywhere, anytime you want. So let me just draw a container on top of these things. Name this as required. And so all these components in the red box are mandatory components. The rest are optional. And the workers, by the way, you cannot use workers for every type of executor. Only if you want a certain type of executor, which is salary executor, only then you use workers. And one more point is you can split the load of this task or the flow by splitting these containers or components into different machines and then combining it together. So you can just split the load however you want. That's why Airflow is so easy for the scalability, and it is so it's so modern tool. And there is one more thing I have to talk about in this architecture is when you use workers, when you use salary executor, like I said, you use multiple workers in salary executor, but one worker, the tasks that are given to the workers from the scheduler cannot be directly given to the worker because they are running in the different PC. To actually transfer these tasks to communicate with the worker, we use something called message broker. So we use a message broker as an intermediate component in between the worker and the executor to transfer the task, to deliver the task to the worker. So now just one is fine. So we use message broker to deliver the task that the worker needs to be done. That's it. So this is the whole architecture. And the examples of message broker, the mostly used message brokers include the Redis, there is RabbitHQ. So we use those brokers to deliver the tasks to the workers. Yeah, let's talk about the flow now. Now we write the DAG file. We write the DAG file with the tasks, and then scheduler will pick up the file. If there is no DAG processor, the DAG parsing will be done by scheduler itself because scheduler is the brain. But if there is DAG processor, the DAG will first take it. You know what? Let me just write it here. Okay. First, DAG is parsed. First, the DAG is parsed. If the DAG processor is actually active, then the DAG parsed in the DAG processor or scheduler handles the DAG parsing as well if there is no DAG processor. And then it gets the blueprint of the DAG and then save that blueprint in the metadata database. Just the DAG blueprint. You don't save the DAG in the metadata database. It saves the blueprint of the DAG in the database, and also the scheduled DAG runs. The schedule when to do the DAG runs will also be stored in the metadata database. That is handled by scheduler. Scheduler stores everything. It writes everything in the metadata database about the DAG runs. So DAG is parsed and then scheduled. I spelled it right. Where it is scheduled. And then the executor, then it asks, the scheduler asks executor to run this task. So it assigns the task to the executor. Then the executor will split this task accordingly, according to which, and it sends to the worker, depending on which worker is actually available to run the tasks. So it splits the work to the workers if there exists any worker. So if it is a salary, then only then it splits the work, or else it just executes. If it is local, it just executes in the same machine. So yeah, so the DAG is scheduled, and then DAG is parsed, DAG is scheduled, and then sent to the executor. Sent to executor. And the executor sends those tasks to split those tasks to the workers, or if it is just local executor or Kubernetes, it runs on the same machine. And then the logs that are generated while the DAG runs will be written to metadata database by the worker. The task runs, it can be the failed runs, or it can be the successful runs. All the logs will be written back to the metadata database. And then that's it. After everything happens, web server will read from the metadata database and show us in the UI about the the updates will be shown to us using the web server. That's how the flow goes. Okay, let me just close this. So if you still didn't get what all these components do separately, let's clear that up first. Okay. Let's start with the scheduler. Let's say scheduler is a decision maker. So scheduler is a decision maker. It's just a decision maker. It don't run the task. It just decides when to run and how to run. Now, don't decide how to run. It just decides, decides when to run and how to run. And next we have executor. Which is the launcher. So it's still, executor doesn't run the task. Executor launches the task to the other workers so they can run. So it splits the task between the workers. Then we have worker. So worker is the one who runs the task. So worker is the runner. Executor is the launcher. Worker is the runner. Then we have the database. Say DB. It's just memory. Database is just memory to store the logs and the task state. And lastly, we have web server, which is also called API server, like I said. So this is just for the visibility. So we can say it is just like a dashboard to show what's happening. Even with the web server, we can still execute the DAGs, but we cannot see what's happening. But web server makes it easier for us to monitor the DAG runs. So I think it is clear now. The scheduler is the decision maker. It decides when to run and where to run, how to run. Executor is the one who launches the task, but it doesn't run the task. Worker is the one who runs the task. Executor splits the task between the workers. It only splits the task with the workers who are actually available. And then database is a memory. Just like the name says, it's just a personal database for the Airflow, and then web server is for the visibility. I think now it is clear. I repeated these architecture explanation over and over again just to make you clear, because I'm not satisfied with my explanation for the first time, so I just explained it multiple times so you'll get it clear. Okay, so I think you're clear with the architecture now. Let's move on to the next topic. Now let's dive deep into executors now, because the other topics we know what they are, but there are a few other types of executors we have to know. I think I already named those types of executors, right? The types of executors include local executor, Celery executor, and then there is Kubernetes executor, and there is also sequential executor. It is so closely identical to local executor, but there is one slight difference between them. That's it. Basically, these are the types of executors. The type of executor doesn't change the task or the logic of the task. It only changes how these tasks will execute. That's it. And executor lets us scale horizontally. Whenever we add a new component to this architecture, we're just scaling vertically. But when we add more, what executor does is it scales vertically. It adds more workers to work parallelly on the same DAG, so it scales horizontally. Now, talking about the types of executors, first one is the local executor, right? First one is the local executor. This is the simplest executor. So I'm going to draw the architecture of all the executors and how they work for all three of them. like I said, I'm not going to draw the sequential executor because that is so identical to the local one. But the difference between the local executor and the sequential executor is, in local executor, all the tasks run parallelly, whereas in sequential executor, it only runs one task at a time. The next task will wait until the task that is running is successfully executed. That's the difference between the local executor and the sequential executor. But the rest of the architecture is identical to local executor. Of the local executor, I mean, it's a basic executor, so I'm going to draw that. It's just 3 blocks. Resize it. I think it's too big. Okay. First, it has the scheduler at the top. Then have the local executor underneath it, and an arrow here. That should do. Local executor doesn't have any workers, extra workers. It just has one worker. So this architecture is so simple because it just has one worker. That is the same machine. Same machine worker. The part we have to talk about this local executor is, in this executor, the scheduler and the worker, all of the setup lives on the same machine. We don't split the work to different machines. Everything is just native in the same machine. But here's the thing: local executor is not production grade, which means you cannot. When you work with the real companies, you don't see local executor. But what local executor is useful is for the students who learn, or for the local testing, we use local executor because it's so simple to set up. But all tasks that we run in this executor runs on the same machine, so it won't divide. That's why the architecture is simple, so you can just easily, set up the infrastructure for that, and you can run. But this good for learning, but not for not production grade. This good for learning or testing or development, but it's not good for the production grade. Now that is local executor. Now we have celery executor, which is quite different. I'm going to copy the same thing. Celery executor, the task runs. It also starts from the scheduler. Okay, so by the way, whatever I'm saying now about the executor is about just this part, not the whole architecture. This is not the whole architecture. So this is not the whole architecture. I'm just talking about that particular executor part, showing you how the architecture works in these types of executors. This is not the whole architecture. On top of the scheduler, we have a DAC processor, or we have metadata database at the bottom of the executor. But this is just for the executor part. So like any other system, we also get we will get the DAG plan and the blueprint from the scheduler. Then we have scheduler, the salary executor at the bottom. Executor. We have salary executor at the bottom. Underneath salary executor, we will have a message broker. And underneath that, finally, we have distributed workers. This is the architecture of it. So we have the salary executor at the bottom, and then the tasks the salary executor wants to execute will be transferred to the worker with the message broker, like I said, to the worker. I said distributed workers because it is not just one single worker, there are multiple workers, can be any number of workers. We can configure them according to our needs or load. So I said distributed workers, and these work will be distributed throughout the workers that are available through the message broker. So it delivers the message from the executor to the worker. That is the role of message broker. One more point I have to add is this executor is a classic production grade executor, and it is also stable and scalable, horizontally scalable. Like I said, executor allows us to scale horizontally, right? Local executor, we cannot scale horizontally, but whereas salary executor, we can scale horizontally because we can use multiple workers for the same DAG file, and we can assign the tasks in the DAG file to different workers. That's why this is horizontally scalable. And lastly, we have Kubernetes. I think I spelled it wrong. I'm terrible at spelling words. Copy this block. So this will also, so the DAG sends the, the DAG runs, and then underneath it we have Kubernetes executor, and then these blocks. Unlike salary executor, Kubernetes executor eliminates the use of message broker. We don't need message broker in this executor architecture. So it right away can access the worker. Well, where salary executor is production grade, and we can have constant workloads to that salary executor, but what's different in Kubernetes executor is it is modern and cloud native. Don't use VMs, virtual machines, or any host physical machines with you in Kubernetes. Everything is cloud native, and that's why it is modern, and it is also auto scalable. It can start and close the pods according to the load. Let's say there are 3 tasks. It opened 3 pods. Pods are nothing but workers, by the way. In Kubernetes, we call them pods, but pods are actually workers, like in Celery. So instead of having particular number of workers working constantly, we don't use those workers. Those workers get created or eliminated according to our need. So that reduces the billing cost, because when I say billing cost, what I mean is, because Kubernetes is cloud native, the cloud platform that we use to initialize these Kubernetes charges us with certain amount, and that amount actually depends on how long we run the number of pods. So that's why auto scaling is a good feature. So only when a huge, only the pods that are required for the the load that we have will be started, and the rest will be eliminated. Well, the thing with Kubernetes is it is powerful than Celery in theory, but it is so complex. It is operationally complex. It is hard to set up and manage than Celery Executor. But this is modern, and it is better than Celery Executor in a lot of factors. But yeah, it still saves a lot of computational power, right? Let's say the DAG has a lot of tasks, and in Celery Executor we can assign the task to the workers. But if we exceed the limit, the tasks exceed the load limit of that workers, these tasks should wait in the queue until one of those workers will get available. But whereas in Kubernetes, it don't need to wait for any of the pods. It just creates the new one for that particular task, and it eliminates after the task is done. So that is a big feature in Kubernetes Executor. But yes, these 3 are the types of executors. It's actually 4, including the sequential executor, but these 3 are the main. To the next slide, we have I have the slide created, building blocks of Airflow. Same thing, it lists all the 3 executors: local executor, Celery executor, and Kubernetes executor. And I already talked about these things. The local one runs on the same machine, the Celery one runs on distributed workers, and the Kubernetes work on 1 pod per task. The scalability for local executor is low because we only use 1 worker, that is 1 machine for every component. We're not even going to split those components with all the machines. We just run all the components in 1 single machine. So the scalability is so low, whereas in Celery Executor, it is from medium to high. It stopped at high because we can only scale it to a distinct number of workers. But whereas in Kubernetes, it is always ready for the heavy load, for unexpected loads that are coming in. And also it is also best for that type of situations, the Kubernetes one. And also it is also best to save the computational power, because let's say you open all the workers, you make all the machines to run every day, right? So let's say you make 100 workers run every day. Even the data load is just even the data incoming is just needs 30 workers, but still you have to run these 100 workers because you don't know what can happen. But whereas in Kubernetes, you don't control the number of workers you hold, because Kubernetes handles it all. You don't do anything. Right, when the load increases, the number of pods increases. If the load decreases, the extra pods will be eliminated and the pods also decreases automatically. So yes, it is very good for scalability, but setup complexity, local executor is a very low complex. It is so easy to set up local executor, but Saturday executor is a bit complicated because we also need to, you know, set up the workers in different machines. It can be VMs or it can be in actual machines, physical machines. But the setup is quite complex than local executor. And then there is Kubernetes, which is with high complexity for setup, but it is worth it. And then we have typical use. Local executor for learning, which we are going to use in this video. I'm going to show you how we set up local executor in our PC using Docker. And then we have Saturday executor, which is a classic production model executor. And then we have modern and cloud native Kubernetes. Show you how we can install a local executor in our local PC. Basically, there are a lot of ways to install Airflow in our PC. We can just directly install using Python, but I'm choosing to install Airflow as a Docker image because it is a lot cleaner than just installing right on your local PC. Because it is, once you're done with the learning process, if you want to get rid of that files and stuff that Airflow created, it is a hard job to do. But when you create an image in Docker, it is a lot easier. You can just, you know, take the files down a lot easier than the local installation. So I'm going with the Docker one here. To install Airflow in Docker, first we have to install Docker Desktop in our PC. So I'm going to show you how we do that. Search Docker Desktop, or I'm going to leave the link in the description so you can use that. And you choose your specified specifications here, and then just install it with the default settings. You don't need to change any installation settings. You can just install with the default settings. You don't even need to log in with your account. It asks you for the login or credentials, or to create an account. You don't need to do any of that. You can just skip the login, and if you skip the login, you will be landing in this page. This is the home page where you can see the containers. This is the container page, not the home page, by the way. This is the container page. Like I said, I did not sign in myself, so you don't have to sign in. You can just skip the sign in process. Yeah, you just install Docker Desktop with the default installation settings. And then the next step is to create a folder. Create that in C drive. Head to users. Your username, by the way. Here, create a folder named anything you want. I'm gonna name it Airflow. Did I name it? No. Airflow Docker. Just an empty folder. Now, I'm going to give you another link to download the compose file, because we are creating an image in Docker, but we don't have time to create the image ourselves, a custom image for the Airflow. So I'm going to give you the official link, which redirects to a page where you can download the compose file from the Airflow official website. So you can use that link to download the docker compose.yaml file. I'm going to copy that, paste it here. Just like that. Oh, you don't even redirect to a web page. It just downloads the file directly. I mean, you can find this file from the web page, but you just need to do a little browsing. But if you use the link that I give you, you can directly download the file right away. And by the time you watch this video, if the link, the version is updated, the version of Airflow is not 3.1.5, if that is not the latest version, you can just replace this version number with the new one, and that will still download the newer version compose file. Now we have the Docker compose file from which we downloaded from the official website. So let's head to downloads. There is the file. Now crop this, cut that, or copy it. Anything's fine. Head to Airflow Docker, the folder that we just created. Place it here. Now, let me just pin this folder, so I don't need to, go through all the root from the root. Pin to Executors. Yeah. Now I pin the folder here, so I don't need to go all the way from the root. I can just click on this folder. Okay, now we have that. After that, we have to open Docker desktop, and in the bottom right you can see terminal. Click on it. You type in cd airflow docker. In case you never worked with the command line interface, so I'm just going to use this command line interface for just a couple steps. So what I did here is, when I open the PowerShell, the root of the PowerShell is C users and JC, but I changed the directory to Airflow Docker that we just created. When I say directory, I mean folder. So right now I'm inside the Airflow Docker folder, which I created. Now anything I execute here will reflect in that folder. Now I'm inside the Airflow Docker. Here I'm going to run. Now, before going further, I forgot a step. Forgot to tell you a step. First, we have to create a new file inside this folder, a .env file. Let me create it. I'm going to use Visual Studio Code for that, because it is a lot easier to write a code than writing the code in Notepad. It is a lot easier to write the code in VS Code and save the files. It's just like writing the code in files, but it is a lot easier to write the code in VS Code. You don't need this, by the way, you don't need this VS Code tool. You can just write this through your Notepad. From here I create a file named .env and say airflow uid equals file 00. any number. I'm going to say 50,000. Let's say 50,000 will do. Now I created a file named .env, which is an environment file. But just not get you confused, I'm going to show you how we can create that from Notepad itself. It just to make it quick, I'm gonna copy that, paste it, Control S, go to the folder and name it .env and switch the type as all files and just save it. Just like that, you can click save. It's the same thing, but I use VS Code, just to make it more easier. It is a lot better to write codes in this editor, so I use that. Now, I created the .env file. My next step will be, let me also show the Docker Compose file first. Here we are using the Compose file, the pre-built file that we downloaded from the Apache Airflow website. But in real life, we can just customize these Airflow components according to our needs. Here I downloaded this from the website, so it has every component, that even the components that we don't need are here. But in the real world, when you work for a company or you work with an organization, we create our customized, containers. We don't use this. This is just for the learning purpose. You see, here in this, we have Postgres by default, which is our metadata database. And by the way, it doesn't necessarily has to be Postgres as our metadata database. It can be MySQL database too. It can be a lot other databases, but Postgres is the best one for our database in Airflow. So it create an image for database, which is fine, which is mandatory, and there is Redis. We don't need Redis here, right? Because we're not going to start a Celery executor because we don't have multiple pieces or multiple virtual machines here. So I'm not going to use Redis. Airflow API server. Remember that when I say this is nothing but web server. Is it web server? Yeah, web server. It's just another name for web server. It is API server. We do need it. It is not necessary, but we're going to keep this because that's the UI. We need the UI for that. Okay, I'm going to take this Reddit out, by the way. I will take it out, but I'm going to show you all the components that are listed. And we have Airflow scheduler. Like I said, Airflow scheduler is mandatory. We cannot take that out. We can take take this one, but we'll keep it because we need the UI to monitor the logs and state, the task state and the DAG state. And then we have Airflow DAG processor. Remember, I said we use DAG processor to reduce the load that is built up on scheduler. So we reduce the load by creating a separate DAG processor which passes the DAG. So this is that. I'm going to keep it as it is too. So I'm not going to take out the DAG processor too. I'm going to keep it. And there is Airflow worker. For local executor, we don't need to create another separate container for Airflow worker because it is all included. We're not going to use separate workers. So I can take this one down too. And there is Airflow triggerer. We don't need that. If we need Airflow in it, it initializes the Airflow containers. And then Airflow CLI, I'll keep it. We don't need the flower. Okay, heading to the beginning. I'm going to take out Redis, right? Before taking out Redis, you also have to take this thing down. Say, you cannot run this container unless you take this thing down as well, because it says depends on. If something depends on Redis, even if you take Redis out, you cannot compose the container because this thing also depends on Redis. So you have to take these two lines down too. And then take the whole Redis definition down. So we don't need that. And then what else? We don't need the Airflow worker. I'm going to take that down to trigger. We don't need, but I'll keep it. That's fine. That doesn't matter, right? And then we don't need flower. Take that down to. If you head to the top, you see this line. Airflow core executor is defined as Celery executor, but here we don't need Celery executor. We're just learning, so we have to switch that from Celery executor to local executor. Just by saying local, you have to switch that too. If you don't want to do any of this stuff and just want to install Airflow, you just want to start Airflow, you can just run the compose file right away. You don't need to take these containers out, but taking these containers out just saves you computational power, you know. So I'm just saying you can just take these things out. Just start a local executor instead of Celery executor, because that takes a lot of computational power compared to local executor. That's why I switched those. But if you don't want to waste your time, you can just right away open open the Docker Compose and turn it up. You can just create the container from the default file itself. That works too. Okay, now I took down Celery executor, that I switched it to local executor. I don't need to change anything else, that's fine. Now save it. So that is the pre-built container Airflow container, right? The compose file for the Airflow container. But I'm going to show you how a customized Airflow container will be. I'm going to show you an example from one of my projects, Banking Modern Data Stack. And here Docker compose file. In this compose file, by the way, I also created a lot other images. I created one for the Kafka. I mean, we don't need any of that. I'm going to go for the Airflow components first. Here, I created Postgres, which is the database that we need. I created Postgres with my own password, user, and Postgres database name, my own one. That is the beauty of customization. We can customize it to our needs. So not this one. This not the this not the metadata database. This is the database. Let me show you. So this is the Airflow metadata database. Airflow Postgres. I created this, and then I created the scheduler, and then I created the Airflow web server, which is the UI. These are we can customize these containers instead of using the pre-built compose file. I can even create my own volumes here. I created this volume by my own. I mean, this is my own volume. You cannot find this. You don't find this in the compose file, by the way. By the way, volumes are the storage spaces which Airflow can access, which Airflow can have access to. So right when I create the container, these these folders will be created in the desired location, which includes DAGs. So DAGs folder is for the DAGs, logs folder is for the logs to store the logs, and the config is for the configs and plugins. to store the plugins. DAGs, this is the folder where we store the DAGs when we write them. So Airflow picks them up automatically. Now we have everything. Head back to Docker. Now we already run cd airflow docker. The next one is to initialize Airflow. To initialize Airflow, the command that we have to run is docker compose up airflow init. Docker compose up means to create the containers. Docker compose down tells the Docker to destroy the containers. Now here we are saying Docker compose up and we are saying airflow init. Run that. Now you'll see these two containers. So airflow init will first initialize all the other containers, and it creates them. It creates the database first, and it creates the other containers. It basically initializes the setup first for us. It takes a few seconds. Now the initialization is done. Now the next step is click on, after the initialization container is stopped. So you can see here, right? The green one says it is running and this one says exited. So this container is not running. Right after it turns to exited, create a new terminal. Click on the plus icon there. Create one. Click cd airflow docker. And now docker compose up. Now we create all the rest of the containers. First, we just created the initialization container, which initializes the database and creates a username and password for that database, metadata database. And now we are composing the rest of the containers. Just like that. We see we kept the DAG processor, we did not touch it. We have the Airflow scheduler and we have the Airflow API server. We did not, I thought we took out the Airflow trigger too. We don't need Airflow trigger, but yeah, that's fine, like I said. But you can take out the Airflow trigger too from the compose file. We just need the DAG processor. We don't even need the DAG processor, but it makes easier for scheduler to run. So I kept it as it is. We just need scheduler. We need API server to actually see the DAGs. That's the UI, so we need that. And then we need this because that's our metadata database. We don't need trigger. And DAG processor is just optional. Now, the init container will still be off and the rest of the containers are running. When you click on this localhost 8080, this link here, it redirects to Airflow page where you can log in. By default, the username and password will be Airflow and Airflow. Both will be Airflow. Just sign in. That's it. You are here in the home page now. So this is the home page. File and run the Docker Compose. You will be able to see all these 4 folders created automatically because those are the volumes that we connected to that container. Like I said, we'll have logs, which stores the log data, the logs of every task in the state, and DAGs. This is the folder. Here's where we place our DAG files in order to Airflow to pick them up. It sends us those DAG files and picks up and then passes like we talked. Then we have plugins, which will be empty because there are no plugins yet. There is configurations. So these 4 folders will be created. Talking about the UI, these not just for the visuals. This is basically like a control center where you can debug, where you can manually trigger a DAG to run, or you can retry everything at one place. So to explore, let's head to DAGs first. To explore more about DAGs, I have a test DAG that I created. I'm going to use that. Let me just show you what it is first. Open with Visual Studio. You see, when I say it is a lot easier to code in Visual Studio, this is what I mean. You see how it is well structured and well colored. So it is so easy to read a code in Visual Studio than in Notepad. Let me show you. When you open this same file in Notepad, this is how it looks. It doesn't have a good structure and good coloring. That's why I use Visual Studio. Now here, I'm not going to explain the DAG. I just want to tell you I'm going to use this DAG to show you how the UI works. I have this DAG already created. So, but first I'm gonna take this line down because I ingest that line to actually ingest an error, to pop an error on the UI. So, but for the first run, I'm going to make it run without any errors. Now, this is not how I have to open it. First, I have to copy this into our repository, into DAX folder. Like I said, we have to put the DAX in the DAX folder. Only then Airflow will scan it, or else it won't. Open with VS Code. Now I'm going to take this line down. That is an exception. Okay. Right now there are 82 tags. 82 tags. I think it is going to pass. It's going to take a few seconds to pass the tag because I just copied it into that, pasted it into that folder. So it's going to take a few seconds to pass it first. After it passes it, we're going to see 83 DAGs here instead of 82. Okay, it took a while to pass it, but finally I see 83 DAGs now, which means, by the way, we can search the DAG by the DAG name, or we can search it by the tag that we define when we write the DAG. I'm going to talk about writing the DAG, actually how to write a DAG in future slides, but for now, yeah, there are 2 methods to search it. You can search it by, filter it by tag or tag. I'm going to filter it by tag that I defined in the DAG file itself. Say training. So that's the only tag here. Oh, it somehow have all the data, the previously executed data. Okay, when I open the tag, so in this tag I defined 4 tasks, all right? And the task IDs are, one is start, and next one is extract data, and the next one is transform data, and then load data. I'm going to zoom it in for you guys. Okay, it's not zooming in for some reason. Whatever. So yeah, in this tag file I defined 4 tasks. One is start, extract data, transform data, and load data. But when I define these tasks, the dependencies between these tags are different. So for the start task, there is no dependency at all. For the extract, there is no dependency in the downstream. But for the transform data, there is a dependency in the downstream, which is extract data. And for the load data, there is also a dependency, which is transform data. Remember when I talked about the example task with a DAG that has 3 tasks, task A, task B, which execute parallelly, and there is task C, which only executes when task B is executed and successfully ran. You can clearly see it right here. Here I used 4 tasks, but the same scenario. Let's say this is task A, which is start. It is independent of any other task. It runs right away when the DAG run is started. So this task is independent of the rest. So it runs automatically when the diagram starts. And also the extract, it is also independent with the other ones. It executes right after the diagram starts. But the transform data and the load data will not start executing. The transform data only executes this one. The transform data only executes if the extract data is executed and there is no error or it is not failed. So only if it is successfully executed, then it goes to transform. Then the transform data will execute. It waits for the extract data to be successful. Same with the load data as well. Load data will not execute. Load data will not execute unless the transform data is executed successfully without any errors. Only then the load data execution starts. So they are all dependent on each other. That's how it works. Now let's show you. So this is the flow diagram. This is a graph view, and there is tree view, which is this one. In this tree view, we can see all the tasks listed row-wise, and the executions are column-wise. When I say that, the tasks are listed row-wise. So these are the 4 tasks which are listed row-wise: extract data, start, transform data, load data. And the executions are listed column-wise. These are the executions. So I executed this tag for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And in those 10 times, 8 times are successful, 8 executions are successful, and the other 2 are failed. And this bar chart, to be technical, it's just a bar chart, and this bar shows how long it took for that particular DAG to execute. Yes. So if you take a look at here, you see transform data failed. When transform data failed, load data never got executed because load data is dependent on transform data. Only if transform data executes, only then the load data will execute. Because transform data failed, load data never got executed. So when you click on that particular task, you can see in the task instance it says upstream failed. Because the upstream failed, the downstream one, the load data, will not get executed. That's how it works. Now let's trigger this once, so you'll see how it works. We can, like I said, we can manually trigger the DAG from the UI. So that is why this is not just a visual UI. This is a control center where you can control all your DAGs and workflows. So I'm going to click trigger here, single run. There is backfill as well. I'm going to talk about backfill later, but for now I'm going to say trigger. You can see which tasks are running. Like I said, these two started running parallelly, right? What's that? So these two started running parallelly, but only after extract data got executed successfully, only then transform data started executed. If you clearly see that, you can find that the difference, the time difference. Now I'm going to add that exception, so it will raise an error now. At transform data, I raised an exception, which is basically an error. I'm going to wantedly put an error here so you can see how it looks if the upstream fails. Let's go back, trigger it manually. Before, you see how it shows when you trigger that in the graph view. Now I'm going to show you the tree view of the DAG when it triggers. Now I'm going to trigger that again. Now before I trigger that, I also want to show you about these asset logs. Oh, clicked the wrong one. Training my pipeline. Here, oh, did I trigger that? I just started running. Right. So here you can see the logs in audit log. Backfill, audit log, code. You can also see the code that you wrote in that DAG file. Now, the raise exception is updated. That means any executions from now will fail. As you see here, it takes time, it still retries. So it stopped at this task, transform data, because we ingested an error in that task, transform data. So we ingested an error at transform data, said raise exception, so it raised an exception. That's why it tries again and again to, it retries basically. It just retries. Let me show you clear. So it is failed first. Now when you click on that, you can see the logs clearly. So it tried once, it failed. Now it tried twice, it failed. Now this is the third try, it is still trying. The third try is also failed. So it tries 3 times before it actually fails, because I defined that as well in my code. Retry as 2. So the first one is the default. So the first one is a try, but the next 2 are the retries. So that's why it says 3 fails. The first one is the default try, and the second and third one is the retry, because I specified 2 retries. And we can see the exact exception that raised because of the error, which is intentional failure right here. So these are the logs. This is the place where we can see the logs and the retries. And this is the error that raised. Exception intentional failure for UI demo, because I raised that exception that shows that. So this is the tree view. And this is the graph view. What else do I left with? Show you how to trigger the tag, show you how to inspect the logs. In case you face any error, you can just hit on that task. Right away, you'll get into the logs, and here in the logs, you just find the error stage here, error log here, and right underneath that, in the first line, you can see the exact error that you're facing. You can just fix it if you know how to fix it, or you can just copy paste it to any language model, the ChatGPT or Gemini. That will give you the solution. It is that easy to actually debug any error that faced by a tag that you created. See, like I said, the upstream fails, the task won't run because it is dependent on that. Now, am I missing something? Okay, I think I covered everything. And if you want to pause any DAG, you just have to toggle that button, and that turns off the DAG. Now it won't run. It kept running because it is scheduled for every minute, so it kept running for 5 times. So when you pause it, it just pauses. It won't run anymore. Homepage, you can actually see how many DAGs are running and how many DAGs have failed. There's one DAG running. Well, I paused it, but still, even if you pause it, the already executed DAG will not pause automatically. It finishes the run and then it won't execute the other DAG runs, the next DAG runs, upcoming ones, when you pause it. That's how you pause it. Just delete the DAG from here. So if your DAG is not passed in the right way, you cannot find your DAG. Go back. So this DAG number will not change, and also it shows a notification here saying what make your DAG fail to pass. So you can just copy that error and ask the ChatGPT or any language model for the solution, or you can just fix it by yourself. Yeah, but the main thing you have to remember is how to check if the tag fails, the errors. Because I did a lot of projects using Airflow, and a lot of times I got comments asking for this. So they say my DAG got error, and how can I fix it? You can just, like I said, you can just go click on that error task, the task that got error, and click on that. And here, right here, you can see the logs here, and right at the log where it says error, in the second line, you can actually see the error that caused the failure. You can just copy that error, give your actual code and the error to ChatGPT and ask it. So this is my DAG code, and this is the error that I got. How to fix it? That's it. It is that simple. Well, our next topic will be writing a DAG file. By the way, this is my day 2 of filming this masterclass. Now, we're out of the theory part, not totally out of it. We still are going to, go through some theory as well, but we did enter the demonstration part. Now we're going to write the DAG file on live. I'm going to write a simple DAG file. I'll show you how we can write those DAG file, how we define a DAG, how we define a task, and all of that stuff. So I'm going to start with writing a simple DAG file. To write a simple DAG file, I'm going to open the VS Code editor. Like I said, you can do this in a regular notepad as well, but this is more efficient to do that, so I'm going to use this. Now, we all know we have to place that .py file. which is the DAG, in the DAGs folder in order to let the Airflow scan the DAG file, or else the Airflow won't scan it. So it should be in the DAGs folder. So I'm creating a file with a name in the DAGs folder. Say I'm going to name it task flow demo, and I'll talk about the name, why I named it task flow demo. I'll talk about it later, but task flow demo. You see, that's just a regular Python file, but what makes it a DAG file is how we define the code inside it. How we define the DAG with the code inside it. To begin with, we're going to import the libraries, the modules from the libraries, whatever we want. So I'm going to import the datetime first. Datetime. From datetime library, I'm going to import datetime module. Before going to the coding part, I think I forgot to show you how we can open the folder in VS Code. So if you're following up with me and you're trying to use VS Code, you can open the folder inside your file manager in the VS Code by clicking here, clicking on the file on the top left, and choose open folder. Click on it and navigate to the folder you want to open in the VS Code. Here in my case is Airflow Docker, and then click select folder. That will pop the folder here, so you can you can see that in the Explorer. And from here you click on the folder name, and when the drop down comes out, then you click on the plus new file icon, or if you want to create a new folder, you click on this button. So I want to create a new file. I'm going to click on that, and then you name the file and you can code it right here. That's how you open it. So now I imported the datetime module. From datetime import, how to say import, from datetime import datetime. So I imported this module to define the start time of the DAG. We have to define the start time of the DAG. So define the start date or start date. I want date time here, date time module. And then I want to import decorators. So datetime is just a Python module, but here I'm going to import task and DAG decorators. These are Airflow modules. So I'm going to import those modules, those decorator modules, from airflow.sdk. SDK stands for Software Development or Developer Kit. And these decorators helps us to define which is task, which is DAG. So we use them to define that. There are a few other different ways to define the DAG and task, but these are one of them. Now let's define a DAG. Begin with, when we use a decorator to define a DAG, this is the format we use. We use @DAG followed by a parenthesis, and inside this parenthesis we define the parameters of the DAG. And the mostly used parameters include schedule. Here we define how often this DAG should run, and this scheduling format has a lot of ways to format it. We are going to talk it in future, but now I'm going to use daily. So I'm going to schedule it every day, so I'm going to use daily here. Just to make it simpler, I'm going to use daily. So this DAG file runs every day, and a comma, and then like I said, we need to define a start date using datetime module that I imported earlier. Usually this can be, I'm going to date it with the today's date, which is 12/19/2025. The format should be year, month, and date. So it should be 2025 12/19 2025 comma 12. I'm going to say 18 instead. Then you do catchup plus false. Now, what is catchup? You see, we define the start date as 2025 12/18. Yeah. So we define the start date as 2025 12/18, right? But imagine if you define the start date as 2025 12, let's say 10. Let me just show you the example. So let's say I defined it as 2025 12/10. Okay, so the DAG should start at 2025 12/10, but I created this DAG and I unpaused it in the Airflow on today's date, which is 19th. Then if catchup is true, and what is today's date? Forgot. So today's date is 2025/12/19. So I say start date as 10, but I actually unpaused it in the Airflow. I started, I unpaused it in the Airflow on 19th. And when I say catch up equals true, it catches up with the flow. Okay, so it is scheduled daily, right? So it should run once every day. So in that case, when I say that, and when I say catch up equals true, it immediately, when I unpause it, it executes 9 more times. It executes for December 10th and 11th and 12th, 13, 14, 15, 16, 17, 18, 19. So it executes 9 times. Is 9 times 3, 4, 5, 6. So it catches up with the start date. So it executes immediately 9 more times right after you unpause it. That's how it works. That's how catchup works. It catches up with the start date. But here we said catchup equals false. So whatever the date you define there, unless the date is in the past, it don't run. It just starts running. It just counts from today. You don't count the past executions. It only counts from present. And if I say start date, if I define the start date to future, let's say if I define it to this 20th of December, take an example, 20th of December or 21st, let's say 21st. So today is 19. It's not, even if you unpause it, the DAG will not run today and tomorrow, which is 20. It's not going to run today and tomorrow. It starts running from 21st. That's how the start date works, and that's how catch-up works. I think you got the concept. Now, in the next line, I'm going to define a few tags for this DAG file. I'm going to say demo. Say task fluff. Now, tags. When you hear tags, when you hear the name tags, what did you get to your mind? Tags, right? This tags, when you define tags, it doesn't affect the DAG, like technically, but why we use tags is for us to make it easier for us to find the DAG in the UI. So I'm trying to think how to explain it. So here we use demo and task class tag. If we don't define tags here, we need to search for the DAG file with the DAG name, and it is so complex when you have a lot of DAG files. Like in real industry, we don't just have one or two DAGs. We have a lot of DAGs running parallelly, and we don't want, if you want to find a DAG out of those stash of DAGs, it is so hard to find it with the name. To make it easier, we define the tags first, so we can choose the tag, and according to the tag we chosen, all the DAG files that has the same tagline or tag will appear on the top. Let me show you practically. So you head to DAGs in the UI. Okay. Here, if you want to search for anything, let's say the one that we used for the UI demo, I also included a few tags in that UI demo file. Let me show you that as well. This one, we use test, right? I'm going to open that file. Okay. In this one, we also define these two tags, which is UI demo and training. So we use these two tags. Now, if I want to search for this tag, for this DAG file in the UI, I can just go to here, filter by tag, filter training, click on that, and just like that I can find my DAG file, and this is the only DAG file that has the tag. And you can stack multiple tags in one search. So here I selected training, and I will also select UI demo, which is also a tag of the same DAG file. And these combination of these two tags make it unique. Now, in my new DAG file, in the new DAG file I'm creating, I'm using demo and task flow. To make it clear for you, I'm going to use training as one of the tag. I'm going to use training as one of the tag. So when I select training here, just as a training here, I will see this DAG file and also the new DAG file I created here. But when I also select task flow as the other tag filter, this will go off and the new DAG that I created will pop up. That's how we search it. So it makes the tags make search a lot easier than searching the name of the DAG. That's why we use it. Okay. Now we know that. And for the next topic, now this is how we define the DAG with the parameters, right? You might think, are these the only parameters that we can use to define it when we define a DAG? No, there are a lot of parameters you can use when you define a DAG, but these are the most important one I mean, I don't say these are the only most important one. There are a lot more, but yeah, these are few of the most important parameters we use when we define a DAG. To actually see all the parameters available when you define a DAG, we can just go to the Airflow official server. I mean, it comes with the practice. You cannot, you know, you cannot just remember all the parameters available for a DAG. It when you start working with the DAG, when you start creating the DAGs, you will eventually know what are important DAGs and what do you need. That's how you remember the DAGs. You cannot remember all the DAGs. There are a lot of DAG parameters, so you cannot remember them. So I'm going to show you. I already have the link ready to open here. You can see these are all the DAG parameters. There is DAG ID, DAG description, schedule, start date, end date, template search path, template unidentified. This is not a decorator, by the way. This is just a DAG. We used a decorator. We used a DAG decorator. We used this one. So for this one, these are the parameters. We have DAG ID, which we used. We have DAG description. We did not use that. We have schedule. I think we did use. Yeah, we did use schedule. Also open. Yeah, we did use schedule. We use start date. We use start date. We can also define end date, and that is the date when the DAG stops running. We can also define the end date. And there are a lot more. And we used Catchup, right? And that's it. We use tags right here. So these are all the parameters for this decorator, and yeah, for every decorator or for every import, there are a lot of parameters you can use, and you can find them on the official website. But I'm talking about the most used ones, and these are the most used ones. Okay, now we're done with the parameters of the DAG. Now let's define the tasks in that DAG. I'm going to define the first task. Now, first we have to define the DAG. We just defined the parameters of the DAG. We have to define the actual DAG now. As flow demo. Here we have to know one thing. This here, whatever the name I define this function with, will be our DAG ID at the end. Here I said task flow underscore demo. So the file name is independent to the DAG ID. The file name will not be the DAG ID. The DAG ID is defined inside the file, inside the inside the code. And this will be our DAG ID right here. Whatever you put the name here, whatever you define the DAG with, will be the DAG ID. So this task flow underscore demo will be the DAG ID for me. Now, in the DAG, I'm going to define our first task. We define the task with this decorator @task, and the task ID will be just like the DAG ID. Whatever the name we put here after the DEF will be the task ID. Extract of. So this extract will be our task ID, and task flow demo will be our DAG ID. You got it, right? I'm going to show you. our other code that we used, UI demo. So yes, DAG ID is this one. This is the DAG ID. So this is the DAG ID, and when we open the DAG, these names are the task IDs. Extract data, start, transform data, load data. These are the task IDs. And here, I think I have to zoom it, right? So you can see it clearly. Now how I can zoom it. Yeah, here. The first task, I define it as extract. So I will see the first task as extract here. And the task IDs will be here, displayed here. This is the task ID. Whatever we name it here, when we define the task, will be our task ID. I'm just trying to zoom it. I got a comment in my last video to zoom the code whenever I write because you guys cannot see it clearly. I'm trying to zoom it. Should be appearance. Zoom in. Control plus equals. Okay. I'm gonna zoom it 2 points. I think this is okay, right? Okay. I think that's fine. Okay, I zoomed in. Now, we gave our task an ID. Now we need to define the task. I'm gonna say data as a variable, and that variable will be a list. Say a list of strings. I'm gonna say apple as first string, and banana as the second string, cherry as our third string, return data. And by the way, I also have to mention one thing. The format I'm coding right now is TaskFlow API format. There are two types of APIs. One is TaskFlow API, which is modern, and there is classic API, which is old, which is kind of old when you write codes. But just remember it. I'm going to talk about it later after I'm done with the whole code. I'm going to talk about this concept. So there is TaskFlow API and there is classic API. And for this coding, I'm using TaskFlow API, which is the modern API. So I'm returning data from this task. And just like that, I defined the first task. Now I'm heading to the second task. I'm defining the second task here. And the task ID will be transformed with data as an argument. I'm passing data as a function argument to this function. Now I'm going to do a basic transformation for that. I'm going to transform all those strings into uppercase. Say transformed data equals item dot upper of method for item data. Now, I don't know what we call it. I think it's list comprehension. I'm going through all the items in the data and in the list of that data, which is this one. So I'm going through all the items in that list: apple, banana, and cherry. And for every item selected, I'm turning it into uppercase. And then I return it again. Transform data. That will be our second task. Extract it, transform. And I'm going to define our third task, which will be our final task, which will be load. And data as our argument for this function. For item in data, print of f strings. Let's have a custom print statement here. Say loaded item. When I define this task as extract, transform, and load, we're not actually doing that. We're just, this, I'm just trying to write a basic Airflow DAG so we can understand how it works. We're not actually extracting anything. We're just creating a list in that in this task, and here we're just transforming the list of items into uppercase, and then here we're just printing. We're not loading it to anything. We're just printing every item in the list as this one. So what we're doing here is we're creating a loop. So it iterates through all the items in the list, which is the data, which is returned from this task. We'll be iterating through all those data, and if we print for every single item, we print loaded colon and the item name. That's it. So it prints 3 items. By the end, it prints 3 items. It says loaded apple. So it should say something like loaded apple, loaded banana, and loaded cherry. So it should print like that. That's what we're doing. We're not extracting or transforming or loading anything. I just named those tasks in that way. Okay, now we also have our third task created. But the tasks are created, but we are not connecting those tasks to each other, right? Here, yeah, this task definition will return the data, the list of items, which is data variable, but this data will not be passed as an argument to this transform unless we connect it. And the same way, the vice versa, the data returned from this transform task will not be passed to the load task unless we connect that. So we need to connect the tasks first in order to run them. So we're going to connect that. I'm going to say, first we have to connect extract and transform. So is it capital T? No. Transform of, we are passing the argument in between the parentheses. So I'm going to put extract there with parentheses. Now we're connected extract to transform. Now whatever extract returns will be passed as an argument into transform. Now we also have to do the same thing with the load and transform. To do that, I'm going to say load off. Now, the output that is returned from extract will be passed as an argument to transform, and the output that is returned from transform will be passed as an argument to load. Now, these three tasks are connected to each other. Wait. Yep. So now they are connected, they are defined, they all have their own responsibility, which is the task they have to do. And one last step is left, that is we need to write the task flow demo 1. We need to write this line at the end to, let's say we need to write that line. We need to write the ID. We need to write the function that we created for the DAG at the end just to make it run, or else the DAG will fail to run. So we have to run the DAG. We have to write the DAG definition that we created at the end again. You know what? I'm going to name it as demo task flow demo 1 because I already wrote another DAG file with task flow demo. They might overlap with each other, so to make it fresh, to make it new, I'm going to add demo 1. And like that, we wrote our first DAG file. It is ready to run. Now, I think I told you I'm going to explain what is task flow API and what is classic API. Now is the time for that. Okay, so this is task flow API, and look at this test code that we written before. We did not write that before, we just executed. When I demonstrated the UI, I just walk you guys through the UI. I use this code. This is classic API, and this is task flow API, which is the modern API. This one is the old API. And I'm going to talk about the difference between those two APIs now. There are a lot of major differences between these two APIs. The most important one is, if we take a look at this one, this old DAG file that we created for the demo, the UI demo, here we imported from Airflow. If you take a look at the first line, we imported from Airflow import DAG, which it wrote in a capital DAG. But in our task flow API, we imported a lowercase DAG. What this is called a decorator, and this is a Python module. This is the actual module, but when we import it and when we define it, we're just creating one DAG explicitly. Whereas this one, it makes the DAG implicit. When I say explicit and implicit, what I mean is, here, if you take a look at the whole code here, okay? Let's take a look at the whole code, what we are doing here, right? For this test DAG file, here we imported DAG, we imported Python operator, and we imported date time. And then we have default args. This is just a dictionary. There's nothing to do with the DAG. I mean, we will assign these values later, but this is just a regular dictionary. We just defined it. And then we have definition. If you take a close look, we are not defining a task here. We're just defining a function here. This is just a function. This is just a regular Python function, followed by the rest of these functions. They are all four of these are just regular Python functions. They are not tasks. And here is where we define the DAG with DAG and DAG ID, just like we did before. DAG ID, start date, schedule. But there are a few extra things I used in this one. We can also use that in task flow. No objection, but These are the new ones. This is just a description to describe the tag ID. This doesn't change anything technical with the tag. It's just an extra parameter to describe the tag. And then we have tag args, and this is where we connected the tag args dictionary. Right here, we said owner as airflow retries equals 2. So when I say retries equals 2, if a task fails, it retries two more times. So it gets 3 chances to execute perfectly. The first one is the default try. So it tries first, and then if it fails, it retries 2 more times. So it gets 3 lives basically. And the retry delay will be 30, which is 30 seconds. We don't want any of that, but I'm just saying the new parameters, talking about the new parameters we added here. And we already talked about catchup, schedule. We have tags, we already talked about it. And then tag as. And here, what we're doing here is where we are connecting these tasks to the tag by assigning the operator to it. You see, we are assigning the Python operator to it with the task ID start and the Python callable. But the Python callable is where we call the function that we create, start task at the beginning. This is just a function back then. Now it is a task. Now it is defined as a task using Python operator. And then we create another one. We define another one. Extract equals for the extract data, and we do the same with the rest of the functions to declare them as tasks. They're not regular functions, they're tasks. But if you actually understand the difference by now, you'll see here to run a Python code, just a simple Python code, we have to use Python operator to declare the task. We have to use Python operator, whereas we did almost the same tasks, the same task in here in the task flow method, but we never declared it as Python operator. You see, we did created a list, we did transformed it, we did declared it as a task, but still we never declared it with a Python operator, because in the modern task flow API, when we use this decorator at the rate task will do it automatically, just for the Python operator, by the way. If you want to use anything else like bash operator, you have to still declare it as bash operator. But for Python operator, you don't have to declare it when you use it as a task. And also, it is this simple to attach a task to a DAG. Whereas in classic API, you first have to define the function, and then you have to declare it as a task, and then you have to connect it with the DAG. That is the difference between explicit DAG, declaring an explicit DAG, and an implicit DAG. This is explicit. You have to connect the task manually again when after you create the functions. You also have to declare the operator that it has to use to actually run the script that you gave it. If it is a bash command, it has to say bash operator. If it is a cloud, if it includes the cloud related stuff, it says cloud operator. And there are a lot of operators. We will talk about operators in the next topic, but for now you just have to remember that. So we have to declare the operator. But for task flow, if you are using Python scripts as a task, you don't have to declare the Python operator, just the Python operator alone. But if you are using any other operators like bash, you have to still declare it, and that's the difference. So, and then at the end, you see this one. This is where we define the dependencies between these tasks. We have 4 tasks, but we only declared the dependencies for 3 because we don't want the start to be part of this dependency. Now we are defining here to run the extract first, and make the transform wait until the extract runs successfully, and then when extract is successfully executed, only then the transform will start executing, and load will start for the transform to get executed. That's how it works. And if you don't include any of the tasks in that dependency, it just start executing right away, parallel to the first task here. That is what we did. That is what I show you in the graph view here. You see, start and extract are parallel to each other, so they execute at the same time. But transform and load data will wait for the upstream to get executed successfully before they start executing. Now you know. Now you see how the relations work, right? So this is how you define the dependency in the classic API, but in the task flow API, you don't have to do any of this. It's just this small code, and for the dependency, you don't have to, you don't have to declare with the arrows or stuff like that, like you did here, the arrows. You don't need to do that. What this does is it automatically declare the dependencies according to the function that you gave it. Here, when you define this one, so before transform runs, no. In order to run transform, the transform needs its argument to be passed, which is extract. So what it does is it automatically waits for the extract to completely execute and then send the output to transform. So transform waits for it. After extract is executed, only then transform will start executing, because transform is dependent on extract. And just like that, vice versa, load will wait until the transform get executed, and when the transform returns the output to load as an argument, only then load starts executing. That's how their dependencies work in the task flow API. It is that simple to declare a task. You just declare it with a decorator at the rate task on top of the task function, and this whole thing will be converted into a task. But that's the difference. But here you have to declare the function first and then convert it into a task by declaring the operator, which is Python operator. Whereas in task flow, you don't have to declare a Python operator. It is automatically declared by itself. And there is one more thing, I think. Yeah. And also the imports, right? So here we imported the DAG, the task, and date time. But here we imported three things. We also imported Python operator, but we don't need Python operator for task flow API. It automatically passes the Python operator automatically. You don't need to declare it in a task flow API. It is best for the tasks that actually based on Python operator. So task flow API is best for the tasks that are based on a Python operator. So you don't need to declare any of that. You can just write the code. And there is one more thing that is different from task flow API to classic API. To show that it is something different, we cannot compare these two. For that, I'm going to show you another thing. I'm going to copy this code, head to a web browser. I'm going to open a ChatGPT. Okay. Here, I gave the task flow API code. Now I'll ask ChatGPT, convert I asked ChatGPT to convert this into classic API with XComs. I'm going to show you how it looks like writing the same code that I just wrote with the task flow API. What if we write that in classic API, the code looks this big. You see that? You see how lengthy the code is? Now let's copy this and compare it, right? Where should I compare it? Should I create a new one? Let's just compare it in this one. I'm not gonna save it. Just gonna use it for comparison right now. Okay, this is what you have to write. You see, it is almost double the size of TaskFlow API. That's the difference between these two. But if you take a look at this, like the TaskFlow, we also need datetime. We also need to import datetime. We also need to import DAG. But we are not using TaskFlow API. We are using the explicit DAG here, not the implicit one. So we import the explicit DAG, and then we also need Python operator, like I said, right? But we also need another thing called XCom. And why do we need that? I will talk about it now, right now. Here, in our first task, which is extract, we all know we have to define the function first in classic API, like I said, right? So we are defining the function. Everything's fine. We're defining the function, right? So we're just creating the list data. We created the list. And what extra is added here is, instead writing return data as just like a normal Python code, we can't just write return data just like normal Python code in classic API. What we have to do here is we have to use XComs to communicate between tasks. All the tasks that are in DAGs, they are like independent nodes. They cannot talk to each other. So whatever a task returns cannot be passed into another task in classic API. That is the limitation for it. Whereas in TaskFlow, you can just fluently, so easily pass that the data, the return data to another task. You see, I'm returning the data, this list from this task, and so easily I passed it to the other task without any extra effort. But here we have to define the XCOM push in the function definition where we are pushing the data out. All right. So here we have to define the XCOM push in the function, and in the function where the data is receiving, we have to use XCOM pull for that. So it is pulling the data out of that XCOM. That's how we have to do it. And for the data that is pushing out of the transform, we have to use XCOM push again, right? And then we have to pull it back in again from this definition. That's how they communicate. So it is so hard to communicate between tasks too in classic API. That is one of the limitations too. Remember this term XCOM, we will dive deep into it later, but remember that. I don't say we don't need XCOM at all, but for Python functions, for the tasks that are based on Python, we don't need XCOM when we use TaskFlow. But we do actually need XCOM, and so we'll dive deep into XCOM, the concept XCOM in later. Okay, I think you got it right. You got the difference between the classic API and the TaskFlow API. Now we haven't yet ran this DAG, so I'm going to save this DAG first. I saved it. Now let me head back to the UI, the web server, DAGs. Oh, it is already passed. It used to be 83 DAGs, now it is 84 DAGs. Now filtering by DAGs, filtering by tags, TAG, not DAG. Filtering by tags. I declared the same tag for both the DAGs, right? Just to show you the difference. So I'm going to use the first tag, which is training. There you go. Training. Now we have two DAG files with the same keyword, but if I use my second tag that I defined, which is task flow, oh, you don't filter out the other one. It includes both the tags. I think I have to apologize here because task flow is not part of the tags that UI demo pipeline has, but it still is here because it don't, you know, take out the DAG files that doesn't have the DAG. It just adds up. You don't take out you don't exactly, it doesn't exactly need to match that these tags. Yeah. Okay, whatever. So that's how you search it. We got it right. Task flow demo. Now we trigger this. You see, extract, transform, and load. I said these are the task IDs: extract, transform, and load. Now let's take a look at the graph. You see, we did not use the arrows like in the classic API. We just used these functions. We just use this, and they are dependent. They already, the dependencies are automatically defined. We did not define the dependencies using the arrows like this, but still the dependencies are there. Now let's trigger it. I just realized here when I returned from the transform task, I did not spell the name right. I just spelled it transform, not transformed. That's the mistake I did. Now I have to let the DAG refresh with the new yeah, it is refreshed. Now it is transformed. Okay. Now let's trigger this. This is ironic, but I just found the reason behind this error. I'm getting this error when I run that. It still runs, the whole execution is done, the DAG is run, but when I try to open the logs of one particular task, it shows this error. Because remember when I talked about the start date and change the date to future? Now, because I defined the DAG start date as future, and when I trigger it, it takes it as an invalid DAG run, so it won't show the logs. That's the error. Now let me just switch the date to the past. Forgot to switch it back. I just shown you the example and I forgot to switch it back. Now let's reload this. Code. Yep. Now it should work. There you go. So extract runs first and then transform and then load. Now it works. Now we can see the logs too. You see, these are all the logs, but I'm going to talk about the important one. It's done right here. It is returned. The values are returned. These the core part of extract. We're just returning these values, right? We're just returning this list of values. So it is done. And for the next task, which is transform, we're going to return capitals, the uppercase. You see, That is what we transformed in the transform data. We transform the items into uppercases. Here the apple, banana, and cherry are in uppercase. So that executor, and then in the load, we just printed all those three objects to print separately as loaded with semicolon. Here it is. Loaded semicolon apple, loaded semicolon banana, and cherry. So that is executed successfully. It took me like 15 minutes to figure out what error I got there. But yeah, that was the error. Because the date, the start date was in future, that popped the error. It, it, it just assumes a task or the DAG run as invalid, so it doesn't create a log for that. It won't create the log for that. And one more thing, whenever our code, our DAG has any XComs, XComs, when I talked about XComs, the XComs that are used to communicate between two tasks, if you have any XComs in our DAG file, they will be appeared here in this panel. Okay, let's head to the next topic. Now let's talk about operators and their categories. We already talked about operator, we already talked about Python operator, right? But now we are going to dive deep into it with demonstrations for a few of the operators available, the most used operators. Operator is like a template. It is not responsible for the execution of the task, but it says what to happen when that task is run. So it says what to happen when the task is run, but it won't execute the task. It is not responsible for that. And talking about operators, the main operators include action operators, transfer operators, and sensor operators. Those are the major operators. Where action operators are responsible to do something, they are used to run a code or a command, which includes the operators like a Python operator that we already used, and bash operator. If you want to run a bash command, so you can craft a task to make that bash command run. So operator says, okay, when these tasks run that particular bash command and give the output. So operator says what to do when that task runs. And there is transfer operator, which is responsible to move data between systems. So it moves data between a system to another system. Let's say if you want to move data from Snowflake, to Google Cloud Storage, we can use transfer operator, which pulls out the data that is in the Snowflake or in the GCS, which pulls out the data from GCS and stores it in Snowflake. It just transfers. So we use those operators called transfer operators to do that. There are a few examples. There are operators for GCS, Google Cloud Storage, and there are operators for S3 bucket too. And next, we have sensor operators. So these sensor operators wait for something to happen. Let's say you want to your DAG has 3 tasks, all right? Let me draw it. So your DAG has 3 tasks. This is 1, this is 2, and this is 3. So your DAG has 3 tasks, and you define a sensor for task 1. And task 1 is to check, say text. So task 1 is to check the file enters the folder. Let's say your DAG is to extract the file
whenever, no, your task is to, your DAG, the basic, the whole idea of your DAG is to extract the file from Snowflake and ingest it into GCS, but it should only get the file if the sensor get triggered, and the sensor checks if there is any new file got uploaded to that particular uh, storage space or Snowflake. So that is the task one. So you define a sensor to check if there is any file enter the folder. Only then it goes to task 2, and then it goes to task 3. If there is no file entered and the sensor the sensor is not triggered, when we define the sensor, we will give a time bracket that says how long the sensor should wait before the file get entered into the folder. Within that time range, if there is no file entered the folder, that task will get failed. We can also define the retries. Even after the retries, the file didn't enter the folder, it just fails. That's how sensor work. Only if the file enters that folder, the desired file that we that we customized in the task 1, if that file actually enters to the folder, that is the only way the sensor get triggered, and then it proceeds to task 2, or else the task 1 fails. That's how sensors work. So there are these operators. We are going to see a demonstration for action operators, transfer operators, and sensor operators, all 3 of them. We will see an example for each one of them. And another topic we have to talk about is hooks. Operators say what should happen when this task run, right? So operator is like a template, and hooks are like connections. When you want to connect to an external system, or you want to authorize an external system, let's say if you want to connect to Google Cloud Storage, and that is an external system, right? That is not part of the system, that is external system. And if you want to connect to that Google Cloud Storage, hooks are used. We can connect to that using hook. So that's how hooks are used. These also one of the important topic to know. Operators are the templates that says how the code, what happens when the task is run, and then hooks are the one responsible to connect to the external system. It can be authentication, or it can be pulling out the files from it, any of it. Now we're done with the theory. Let's go to the demonstration part now. First, let's have a demonstration of action operator. Let me just close this slide and head to VS Code. Create a new DAG. Let's create a new DAG and call it operator demo.py. For the demonstration of action operator, I'm going to pick bash operator because that is one of the action operator. We already saw how Python operator works, right? We know that. We know how Python operator works. Now let's see how bash operator works. Talking about operators, we already talked about task flow, which is the modern API, and there is classic API. And I said in task flow, we can only automate. We don't need to define a Python operator when we run Python statements, Python codes, or Python scripts. But if that is any other operator you want to use, you still have to define it. Task flow API is only, to say that in one word, task flow is API is only, allows Python operator, the Python task to run without Python operator definition. Or else you have to define the operator first. Then only then you can actually use that operator. Okay, for this, let's import first the date time first. And then the decorator. These are the two imports that we did in all of these codes that we wrote today. Now on top of that, we're going to import bash operator too. And that is an Airflow operator. So we're going to say Airflow dot operators dot bash import bash operator. Okay, that is the extra import that we're going to, the extra module that we're going to import. And then we have to define the DAG first. To define the DAG, we imported the decorator already, and we're going to use the modern task flow method for that. To define the DAG with the parameters DAG ID, I'm going to call it bash operator. Bash operator demo. And then start date equals date time, should be the past time or present time, cannot be the future time. Date time of 2025 of 18. And then schedule equals, to make it easier and simpler, I'm going to use daily. And catchup equals false, comma. And for the tags, I'm going to say bash demo. The tag should be unique, right? So it is a lot easier to find it using that tag. Okay. And then now we define the DAG. I spelled it wrong here. I just found out. With DAG ID. Now we define the tag. Now we define the task. Right now, we're just demonstrating. We just want to demonstrate one task, and that is action operator, which is bash operator. So we just have one task in this tag. We will just have one task. So define task. Bash operator. Now I will define it. Now we are defining the task ID here. Let's say, give the big ID. Let's say list tag folder files. I'm going to write a tag that lists all the files that are in that particular folder. That's it. Like that, we define the task. Now I have to talk about the task. Here, we are defining the operator first. That's the bash operator, and the task ID, which is list tag folders files. I'm assigning the task ID here, and then this is the bash command that we are giving it. So the operator says, okay, operator says the executor to run this bash command, and the bash command is this. This is the bash command. Echo in bash command is just like for the readability, it just says, okay, print this to the terminal. So it prints it. It's just like print, print statement. So it prints. This is just a static string. So it prints as it is. Files in DAX folder. So it prints as it is. And then, so it says, so it prints this one, and we use AND operator in this bash command, and then we print the list of all the files that are present in the DAX folder. I chosen the DAX folder because Airflow only has access to that. And let me say why. Because when we define the Docker compose file, let me show you with the compose file itself. So this is our Docker compose file, right? So when we define the compose file, when we define it, we define the volumes too. Volumes are the storage spaces which Airflow have access to. and Airflow have access to just these 4 volumes. Airflow can read or write from these volumes. Any other volume in your local PC, Airflow doesn't have access to that. So Airflow can only access these volumes. It can access tags, logs, configs, and plugins. So if you even, where is it? Let me close this. So if you switch this DAX, instead of DAX, if you switch it to logs, it prints the list of files that are stored in the logs, files and folders. So it only accesses these volumes. So that's why I have to pick one of those volumes. If you want to add any other volume here, you can just define it before you turn the containers up, or else you just turn the containers down and then add your volume here. Let's say if you, I think I already showed you the example with my previous project, right, where I defined another extra volume here, which is banking dbt, I think. So we have to define the volume here before we can access it through Airflow. So we can access tags. These are we route to it. It starts with opt and /airflow/dags. Everything in this folder that we created. So it can access everything inside here, because here is this is a place where we initialize the Docker container, which is our Airflow. So that's why it can have access to any of the files in that folder. So yes, with this bash command, we will print this static string, which is files in DAG folder, and the list of files and folders that are present in the folder named DAGs. Okay, now we define the task. Then we have at the end, we have to write the DAG definition again at the end, right? So the name of the DAG definition. This is the DAG definition. So we're going to type that in at the end, right here. And that should do. Now let's go check out the UI and see if our DAG file is here. It is here, but okay. So it already found an error. I typed in from instead of import here. Should be import. Now that should be fixed. Okay, that is fixed. And what was our tag? Our tag was bash demo. Bash demo. There you go. Tasks. Right now we only have one task, which is list DAG folders, folder files. Let's trigger it. Okay. Now when we audit the logs, we should be able to see, so it says output. If we go down to this line from here, so it lists all the folders and the files that are inside the DAGs folder. Let me show you. This is the DAGs folder, and there are 4 entities stored in this folder, which is a folder that is PyCatch, and there are 3 files, 3 Python files: operator demo, task flow demo, test demo. And you can see all of those listed here: operator demo, task flow demo, test.api. So that is working. That's how we run any operators. any action operators. So we're done with the first operator demonstration. Now heading to our second operator, which is transfer operator. Right now I only have access to Google Cloud Storage. So I have access to Google Cloud Platform, so I have access to Google Cloud Storage, but we can do the same process with any of the storage available. It can be AWS S3 bucket, or it can be Azure Blob Storage. It can be any of the storage available that you want to connect. The the process is the same, but the operator that you use will be quite different than what I'm going to use now, because I'm connecting to Google Cloud Storage. If you're connecting to Google Blob Storage, Azure Blob Storage, the operator will be separate. You just need to Google it and you'll get it. But I'm going to show how we can connect to Google Cloud Storage now using Airflow, using transfer operator, by the way, not Airflow, using transfer operator. Okay, let's head back to our code. I'm going to use the same code. Okay, what I'm going to do is I'm going to ingest a file from my local PC to Google Cloud Storage. I'm going to upload it to Google Cloud Storage through the DAG file. I'm not going to do that manually. I'm going to code it and give it to Airflow to run it. Let that be our next task. Should be here. Before that, we have to import an operator for that. Airflow providers.google. So this is the operator that we are going to use, because we are going to transfer the file from local PC to Google Cloud Storage. That's why we use local file system to GCS operator. But if you are doing a different task, let's say if you're transferring a file from local PC to blob storage, you can just Google it, or you can ask ChatGPT, and ChatGPT gives the operator, or ChatGPT even gives you the whole task that you have to write to execute that in the DAG. But for our case, I'm going to use local file system because we're going to use GCS. Now let's define our second task. Let me just separate this just for the readability. I'm going to separate them. Just a single line space. Say cloud operator upload to GCS. Local file system to GCS operator. That's correct. And open a parenthesis. Define the task ID. Say upload CSV to GCS. GCS, comma. We have to define the source, which is src. The source will be the DAX folder, because I don't have any access to a separate folder. So I'm going to use DAX folder to fetch for my source file. And the file to upload to GCS will be, oh, sorry, will be a CSV file that I already kept ready. It can be any file, but I'm going to choose this one, dailysales.csv, which I used in my last project, I think. So I'm going to use the same file here. For now, I'm going to place it here outside the DAG. I'll switch it back to inside, switch it into DAX folder later, but for now it is outside DAX folder. Okay, here we're going to define the source. Like I said, it goes to OPT, Airflow, DAX. Say DAX slash. Now we have to say the file name. We have to define the file name that is getting ingested into the Google Cloud Storage. And the file name is daily_sales.csv. Okay, that is defined, comma, and in the next line, we define the destination. Before we define the source, now the destination. For now, I'm going to say demo slash daily sales CSV. Well, we haven't created a bucket yet in Google Cloud Storage, but if we create the bucket, if we connect it to the Airflow with the connection string, with the authentication and stuff, if everything is done, when I define this destination, it stores the file in the destination. But if there is a folder already named demo, it just uses that folder and it saves the csv.csv file in that folder. If there is no folder at all, it creates a separate folder called with the name demo, and then it stores this .csv file inside that folder that it created. Okay, we have the destination. Now bucket. We don't have the bucket yet because we have not created it yet. So I'm going to leave it empty right for now. I will fill it later. And then we have to define GCS connection ID. We haven't defined the GCS connection ID yet too. So I will leave it here. I'm going to save it. First, let me pause this tag. Forgot to pause it. Now, connecting to any cloud platform is not easy. It has a lot of firewalls to to deal with. So for any cloud storage, it can be GCS, it can be Azure Blob Storage, it can be AWS S3. You have to be an authorized persona to get that files or to ingest files into that cloud storage. Now we're going to deal with authentication. Now we're going to deal with the authorization of Google Cloud Storage. We will create a service account. We will give the roles to it. If you don't know about it, if you don't know about RBIC, I'm going to give you a quick glimpse about it. So in Google Cloud Storage or Azure or any cloud platform, the access to any of the objects or any of the entities in that cloud platform the access is defined by the roles. We don't just give access. Let's say, for example, we have a cloud storage, right? If you want to write to the cloud storage, if I'm the manager and you are let's say you are an employee, and if I want to give you access to just read from that cloud storage, I don't just give you the read privilege direct to your employee ID. What I do is I create a role, or I use a predefined role that is offered by the cloud platform. I and then I give privileges to that particular role, and then I assign that role to multiple peoples that have the same that needs the same privilege. Uh, you know what I mean? Because when we work for a company, there won't be just one person that needs read access. There can be multiple people, right? And giving access to multiple people for multiple privileges might be so hard. So instead, we just give privileges to roles, and we assign those roles to that person. So any privileges that is connected to this role will be assigned to that particular persona. That's how it works. So we have to now what we have to do is we have to create a service account, and then we assign the read and write permission to that service account for on the Google Cloud Storage bucket, and then we use that connection ID here in GCP connection ID. That's how we do it. And then here we give the bucket name here, and this here we give the connection ID. Okay, now let's head to Google Cloud Platform. We are here. Head to Cloud Storage. Now let's create a bucket. This is where we store our file. I'm going to name it Airflow demo GCS J, Airflow demo GCS J, and then here I'm going to choose region, soft delete. I'm going to uncheck soft delete. It is just waste of storage, so I'm going to uncheck that. And that's it. Create, confirm. Now we have the bucket ready. So we can just copy this bucket ID and paste it here, because we already have it, we already created it, but we don't have the connection ID yet. To get the connection ID, we have to click on the 3 lines again. We have to go to IAM. IAM stands for Identity and Access Management. Now we are going to get the privileges by creating a service account and assigning the privileges to that service account and using that connection ID from that. Okay, we are here now. Click on service accounts. Now we have to create a new service account. So click on create service account. I think that's fine. Okay. I'm going to give it a name. Say Airflow GCS. SA. SA stands for service account. So we gave it a name. Create and continue. Now that will create a service account. The service account is created now. Now we are going to give the privileges for that account. To get the write and read privilege, there is a predefined role already, and that role is called storage object admin. So admin has every right on that particular storage. So we're going to give admin privilege for the storage for that service account. Continue and done. Now we have the account where we can access the storage from, and we have the privileges that are given to that account. Now what we have to do is click on the service account that we just created. Switch to keys. Click on add key. Create new key. Make sure JSON is checked and then hit create. This will create a JSON file which allows us to have the role of storage object admin. With this connection string or whatever it is, with this file we can have access to that storage as an admin. Now we got that. What we have to do now is have to head to downloads. This is the JSON file I just downloaded for the access. Going to cut that and paste it somewhere in DAX. Yep. Paste it inside DAX here. Paste it. And then we have to head back to Airflow. Head back to Airflow and click on admin, click on connections. Now we are hooking up with Google Cloud Storage here. Click add connection. Write a name for the connection ID. Let's say Google Cloud default. Connection type. Like I said, you can connect to any cloud platform. All these are options. You can hook to any of this. We have AWS, we have Azure services, we have Google. We have a lot available here. Okay, I'm going to go choose Google Cloud. Yeah, Google Cloud, and in the extra fields, key file path, I'm going to define the key file that I stored, the path of the key file that I stored. And I stored that in DAX. I'm going to choose that, Apache Airflow, DAX folder, and the file name should be the actual file name, the JSON file name that you downloaded. So you copy this file name and paste it here, replace this with actual JSON file name. So here we are just defining the path where you can find the connection JSON file. And we set the connection type here, which is Google Cloud, and we just assigned an ID for the connection ID. And I think that's it. Now we also have to type in the project ID. Project ID here, right here. We also have to put in the project ID here. When you switch back to Google Cloud Platform and click on the project name, and you can find the project ID, which is this one. I'm going to copy that and head back to Airflow. Paste the project ID here. That's it. click on save. Now we have the hook ready. We just need to call this connection ID in our DAG file. And like that, we will have access to the cloud storage. And what was the connection ID? So this is the connection ID for us now. I'm going to copy that, paste it here in the place of Google connection ID. Now we can run this DAG right away, or we can just define the dependencies between these two tasks. So let's just define the dependencies. Define the dependencies. With the task ID, I'm going to say this should execute before this. We have to use the classic way to define the dependencies, because here we're not using the task flow, right, to define this task. So we have to also declare the dependency as the classic API way. The ID for this is upload CS footage. Paste it. Wait, we should not use the task ID here. We have to use this one. Okay. Yeah, we have to use the classic way here because we define the task in the classic way, because the task flow is only good for Python operators, but any other if you want to use any other operator, like as in our case, we use bash operator for action and GCS operator for transfer operator. So they both are not related to Python operators. So we have to define these tasks in the classic API way. That's why we have to use this format to define the dependency, which is the classic API way. Okay, now we have everything ready. We switch to Airflow UI, go to DAGs, refresh, and find if we find our DAG again, which is with the tag bash demo. There we go. Check the code once. Make sure it is updated. It is updated. Now let's trigger it. The first task is successful, obvious, but the second task failed. And the reason is it says, you see, this is how we check the logs right here. So the second task failed, and it also says the reason why it failed. File not found error. So it says the file you defined is not in that location. And the reason for that error is I never placed that CSV file inside the DAG folder. Remember, I placed it outside the DAG folder. Now I'm going to place it inside the DAG folder. Save. Okay. I don't know why I hit Control S there while I'm in the file manager. Okay, now I switched the file from the root folder to the DAGs folder. Now if I trigger this, let's see if I get any other error. No, I don't get any error. So this is successful, which means the file should successfully be uploaded to Google Cloud Storage bucket. Now let's go check it out. click on the 3 lines and switch to cloud storage, buckets, the bucket that we created. We should see, like I said, we haven't created any folder named demo, so it created a folder named demo by itself, which is this one, and it stored that CSV file inside the demo folder right here. That's how the transfer operator works, which is Google local to Google Cloud Storage operator. Now we know about this, so we've done the demonstration for transfer operator, which is this one. Now we have to head to sensor operators, which is our last operator to demonstrate. So let's do that. What am I doing? I'm going to use the same code again, same DAG again, but I'm going to use another task on top of these 2 tasks that I already defined. Let's say I'm going to say that as task 1 and say to trigger the sensor only if a file named data dailysales.csv is present in that particular folder. Only then the sensor will trigger. I'm going to define it that way. We're back to the same code, the same DAG code, but now we're going to import one more module. Like I said, I'm going to use a file sensor. A sensor to detect the file. So we're going to use a file sensor for this. If we import the file sensor module, airflow.sensor.file system, import file sensor. Perfect. That's going to be our first task, and the bash operator is going to be our second task, and the third one will be our cloud operator. So I'm going to define them first, and then we'll know what that is. Okay. Find file sensor. Of course, we're connecting the wait for CSV class to file sensor. Then the parameters for this file sensor task with task ID. Say wait for comma. So the ID as wait for daily sales CSV. And the file path. By the way, all the codes that I am writing in this masterclass, the codes I'm writing and the codes I used, like the test code and the task demo and the operator demo, and the links that I said, the link for the Docker, the link for the Airflow, Docker Compose, every link. You can find every link that I used in this masterclass in the description down below. Go check it out. X and daily sales dot CSV. Or I'm just going to copy paste. Okay, that's correct. And just like the cloud storage connection, for this sensor, we need a connection ID. We need a connection ID to actually connect to our local PC file, the folder. So we need a connection ID for that as well. We need to initialize a hook for that. Hook interval as 30. Timeout equals 360. Mode equals hook. What I did here is I have to talk about these three parameters, right? I talked till this parameter. I haven't talked about these three. Now, timeout defines how long the task should wait for that particular file to be detected. If the file, the daily sales.csv, is not detected in DAX folder within 360 seconds, the task fails. Just same like the other ones. And no, why did I say that? I don't know why I said that. Okay, yeah. So it times out after 360 seconds. And what is poke interval? This defines how often Airflow have to check that folder for this particular file. So it checks for every 30 seconds, which means, so it checks the folder for six times, maybe. Yeah. So the poke interval is 30. So it checks the folder for every 30 seconds, which means it checks for total of 6 times. So that's how poke interval works. And then mode is poke. Okay, we haven't defined it yet. We defined the skeleton of it. We are missing the fs connection ID. We need to define the hook now. So let's go back to Airflow, head back to admin, connections, add connection. Now let's name it fs default. The connection type here is file path because it is in our local container. And then we define the path here. It is already here, but I'm going to type it. So here we're just initializing the hook to the root of the folder. That's why we haven't defined any path here. We just connecting to the root of the folder. To the volume, to be clear, please not parenthesis, this flower bracket. Click save. Okay, if we head back to DAX, refresh. Now we need to copy this connection ID to the DAG code and fill it up in the connection ID space. Now save this tag. Switch to DAX, refresh. What is the error, by the way? No module named Airflow sensor. So it is supposed to be sensors. I think I typed in sensor. Okay, it should be sensors. Save it. Okay, now our DAG is patched successfully. We should be able to find it. Let's just number the tasks here. These are task 1, task 2, and then task 3, and then we have to define the dependency, or else it won't work. So this is what I did here in this, let's say, micro pipeline. We can call it micro pipeline. Just a mini pipeline. I just created a mini pipeline. First, our first task is to sense the file. So it checks for this the file that is named dailysales.csv. If there is no file named dailysales.csv, it waits for 360 seconds. And for every 30 seconds, it go back to the folder to check for the file. If it still doesn't find the file for 360 seconds, the task fails and it won't go further. It should not go further. So we have to define this task dependency as our first task here and say greater than. Okay, that should do. Now, yeah, if the file is not present and it cannot find the file for 360 seconds, it fails at this task itself. It won't go to the next task. If the first task is executed, the second task will execute too, which will give us the list of files and folders that are present in the DAX folder. And then lastly, it stores that file into Google Cloud Storage. Right now, we already have the file stored, right? Now I'm going to delete the whole folder for now, just to see the sensor, just to prove, just to demonstrate the sensor is actually working. I'm going to delete the file that is already in the bucket. Now the bucket is empty, right? Yep, the bucket is empty. Head back. So it executes this task and then this one and then that. Okay, now it is perfect. Head back to our DAX. And what is our DAG tag? Bash demo. Click on it. Click on that, and there you go. We only have the 3 tasks listed. Let's see if the code is up to date. It is up to date. Everything looks perfect. Now, before triggering it, let me just take that the .csv file out of that folder now. Now, the DAG, the data sales, the daily sales.csv file is not inside the DAG, which means the sensor should not be able to find it. Now let's trigger it. If we trigger that, the DAG run, this first task will stay running for 360 seconds, like I said. We can see that clearly in the tree view here. You see that? So it's been 13 seconds. It is still trying to sense that, trying to find that file, but it cannot. The only way it finds it is if we paste this file in DAX folder. Now, after 30 seconds, we define the poke interval as 30 seconds. So after 30 seconds, it go back, check for that file again, and it finds it now because it is already there. And then it triggers the sensor, and then it goes to the next task, which is bash operator, and then it uploads the file to Google Cloud Storage. If you refresh this, that's going to take 30 seconds, like I said. Now it's 1 minute 6 seconds. There you go. So it took, after 30 seconds, the first run took 30 seconds, and it did not find the file here, right here. And at 1 minute 8 seconds, it found the file, and then it ran the other tasks too. All of them are successful now. Let's go check on the logs now. You see, poking for the file. So it happened 3 times, by the way. It happened 3 times. It did not find the file for the first 2, but for the 3rd time, when it poked the folder, it did found the file, and it says found file, opt daily sales.csv. The log says you everything, every step it executes. The log tells you everything. So there you can see the file is found. And then if you go to, if you head to the next step, which is a bash operator that just lists all the files, which will also include daily sales, daily sales.csv, and then Google Cloud Storage, it says now that is uploaded to Google Cloud Storage. Now we go to bucket and refresh the bucket. We should be able to see that. We should be able to see the file uploaded to the cloud storage bucket. That's how it works. Now we're officially done with the demonstrations for every single operator, the major operators. We've done demonstration for, let me just pause the DAG first before I talk. Don't want to, pause it. Head back to our slides. Now we're done with action operators, we're done with that, we're done with the transfer operators, we're done with the sensor operators. And again, I'm going to give the links for the GitHub repository, which has all these codes and files that you need that I used in this masterclass, so you can download them. Okay, now we're done with the operator, heading to the next topic. Yes, like I said, there are a lot of operators out there. There are like more than 100 operators, and I cannot demonstrate every single one of them, right? But even for these 3 operators to demonstrate them, it took me almost what half an hour or 1 hour. So I cannot demonstrate all of them. We cannot talk about all of them. There are a lot of operators. You can just Google the operators according to the task you're going to execute, and you'll get them. It's that easy. Or we have the language models. We have ChatGPT, Gemini. You can use them to get the actual task code and the DAG, the whole DAG file itself. You can just get that too. But the whole purpose of me demonstrating all these operators and the tasks is to show you how Airflow actually works. I mean, I think there are a lot of misconceptions saying Airflow is a coding language. Now, Airflow, there are a lot of misconceptions. So I just want to, give you guys a basic idea about what Airflow is. I think you understand that. Now, now let's head to the next topic. Our next topic will be XComs, variables, and connections. We already have a glimpse about XComs and connections in our previous demonstrations, right? We used connections. I also talked about XComs, but we are going to dive deep into it. Firstly, XComs. In a DAG, in the runtime, tasks are isolated. Tasks cannot talk to each other. They cannot transfer metadata between each other when they are executing. To deal with that problem, XComs works as a message broker, kind of message broker between them, which transfers the data or messages from one task to another. And here's the definition. XCom lets task exchange small pieces of runtime data during a DAG run. So it just lets you exchange the data between the tasks. It acts like a communication broker. Moreover, we can say it is not like a one or two-way communication. It's just like a stream. Let's say there is task 1, and task 1 I'm going to name it task1. Task1 just pushed a set of a small piece of data into XCOM. Okay, so it pushed so let's say XCOM is like a stream, like kind of a stream. It pushed the data. I'm going to say this bit of data. It is so chaotic. So let's say this. So it pushed a data into the stream. There is task2. So to communicate, in order for task2 to communicate to task1, it cannot communicate it directly, but instead it just pulls this data out from that stream, which is XCOM. So it just pulls the data into task2. At the same time, task3 can also pull the same data, and that's why I said it acts like a stream moreover than a communication device. So it lets the task communicate with each other, but it also acts like a stream. So multiple tasks can communicate with one single task. That's how XComs work. Now let me just close this slide and show you guys. We already saw the code, right? We already saw the classic API code which has XComs in it. Let me show you. So I created that. Okay. I just created a DAC file alone for that classic API code which has XComs in it to just demonstrate how it works. So this is same. This does the same. This whole DAC file does the same tasks that this DAC file does, but this is way longer than the regular task flow API. We already talked about it, but we still need to know how XComs work. I know we don't actually need to use them in any of the applications, but we still have to have knowledge. Let's say in interviews, when you go for Airflow interviews, this is an important topic to know about XComs. And also, even in few systems, they are not still updated. They still work in the old Airflow version. So for that, when you operate any sort of that kind of environment, you have to know about XComs. And still XComs are not taken away in the task flow. We just don't define it in the program, but they still work under the hood. We don't see them, they still work under the hood. And task flow API will handle it all. So yes, XComs are still out there, but we don't define them in the code. That's it. So this is the same code we're defining here. We're passing the arguments, the context arguments. A context is nothing but an airflow thing. So they are just passing that context from Airflow into the task, to be clear. And here, context of TI. TI stands for task instance. So it just, when a task runs, it creates a context task instance. From that is the only way XCOM will know what data to push into the stream or what data to push into XComs. Here we're using context of TI, which is this particular task instance, and we use XCOM push to actually push the data into XComs. And we are giving a unique key, which is extracted data, and value is data, which is this one. We are pushing this list. So we are saying we are giving it a key and we're giving the value to push. And at the receiving side, we use XCOM pull in transform. We use XCOM pull, and we say we give the task ID from which we are getting that the data we're pulling the data out of, which is extract task. Here we just say extract, but the task ID is at the bottom right here. So this is the task ID. So we're extracting from the task ID, which is extract track task, and with the key extracted data, which we defined when we pushed it into XComs. Using that, we pull the data out of that XCOM and we use that in this task. Because the tasks are isolated, we use XComs as a communicator in the middle. So it is just like a middleman. Okay, now I already created this DAG file. Let's head to the UI and I'll demonstrate and I'll show you where we can actually find the XComs. Head to DAGs. So it says 86 tags, which means the tag is already added. And the tags that I gave it is training and classic API. I'm going to search for classic API. There it is. Open that tag. Let me just slide it to the right. Zoom it a little bit. Now we have the same three tasks, okay, which is extract task, transform task, and load task. But now, if we run, it still executes the same way. See? Now, if a task have XCOM, it can be a push or pull. When we click on that block in the graph view, and we switch to XCOM section right here, and we can actually see the XCOM that is created in that task with the key and the DAG ID and the run ID and the task ID, and it has a timestamp and map index and value the XCOM is holding. The value the XCOM is holding here is let me show you. So the value here XCOM is holding is data. We just pushed the data into it, which is this list: apple, banana, and cherry. That is what we see here: apple, banana, and cherry. So it holds that. And if we switch to the next task and switch to XCOM, we pushed another data from this too, remember? And this one has the same list, but with every item with the uppercase: apple, banana, and cherry, but in uppercase. In load task, we don't find any because we haven't pushed anything from that task. That's how XComs work. I think that is clear now. And heading to variables. Variables are like key value pairs, just like the variables we use in Python. But we define the variables in Python code when we write it, right? But here, we can define the variable in Airflow itself. So any DAG that we run can use the variable. It doesn't need to use the value. You can just refer to the variable and it still uses that. So it is just a key value pair stored in Airflow that externalizes configuration. So DAGs don't hard code environment specific values. So we can actually implement this in one of our mini pipeline that we created, which pulls out the CSV file and stores it into Google Cloud Storage. So let's implement the variable concept in that. Head back to that was operator demo. Here, so we have all of this, but I think the best way to demonstrate variable in this DAG file is by replacing this file path, because it is so long, it is so lengthy, and it is repeated over and over again. And if you create a separate variable, a dedicated variable for this path, you can not just use in this DAG, you can use in any DAG that you create in future as well. That's the beauty of defining a variable in Airflow. So instead of writing this lengthy file path, you can just say daily sales CSV file path. So I'm going to show you practically by demonstrating it. So I'm going to head to Airflow UI, click on admin, switch to variables. Here You can import variables or you can just add variable. Click on add variable. You have to define a key here. I'm going to say daily sales file path. I can just paste the path here. Now, whenever I want to access this file, I don't have to go through all the file path. I don't have to hard code all the file path saying /opt/airflow/tags and /daily sales CSV. I can just say daily sales file path, and that key alone will pick this value and assigns to that location. Now let's save that and copy this key that we created. Now in our DAG, if we replace this whole thing, so it is repeated twice, once in the file sensor and once in the cloud operator. I'm going to replace that with the variable key here in both the places. Now I saved it. Now if I run that, it won't break the code. It will still get the value from the key of the variable that we defined in Airflow. Now head back to Airflow UI. Let's run the DAG file now. Okay, there is an error. And what was that? It's not defined. We have to import the variable. I forgot. We have to import the variable module first. When you use a variable in your DAG file, you have to import the variable module. Let's import the module here from airflow.models, import capital V variables. Yep, spelled it right. Now save it, head back to the UI, refresh this. Now it should be gone. Okay, I think we got another error. Cannot import the name from Airflow mod. So I said models. Okay, it is models, but I think yeah, this one's wrong. It should be variable, not variables. So import variable. Now save it. Head back to the UI. Now let's refresh that. Oh, again, what is that? Again it says daily sales file path is not defined. Sorry, I just got confused. I never used these variables in my DAGs, so I just got confused. Okay, so there should be another line. We should define another line here. Where right here we have to define another line saying daily sales file path equals variable dot get of daily sales file path. So you can't just directly use the variable name at the key. You have to first get that variable value using the key and then assign it to another variable, another Python variable, and then assign it to the file path. That's how you do it. I mean, I don't actually use these variables, so I'm not sure about these things. Okay, now it is solved. Let's head to the DAG. What was the tag that I used? Bash demo. Yep, bash demo. Bash operator demo. Code. Okay. Now, actually, we actually haven't hard coded the file path here, but if we still run it, it still works because we call the value using the key of that variable. So you see that the first one successful, second one, and the third one. So that is successful. That's how variables work. You don't hard code any of these things, but they're not secrets, by the way. Secrets are different and variables are different. Variables lets you, write things easily. So if there is any uh, particular thing that repeats a lot of times in your codes, you can just create a variable for that. You can just assign a variable for that, and you can use it in multiple DAGs. So you don't need to type it manually. That's how variables work, just like the Python variables. Okay, head back to the slide. Now we have connections. Connections are secure, reusable definition for external systems that Airflow tasks use to authenticate and connect with without exposing credentials. That's what we did. That's what we already did, right? We just use connection to connect right here in this one. We used connection to connect with Google Cloud Storage and then stored the file inside there. That's how connections work. And I also showed you how we define the connections using the API, using the UI. Just have to click on admin, click on connections. This is where we define the connections before we use the connection ID there. That's how connections work. I think with that, we're done with this slide too. We've gone through XComs, we've gone through variables and connections. So that's good. Head to the next topic. Okay, this topic is about scheduling, catch-up, and backfill. Scheduling includes two types. Scheduling, when I say schedule, I mean scheduling a DAG includes two types. One is cron, where we define the schedules, and the other one is timetables. Cron defines when Airflow should create schedule DAG runs, and timetable explicitly control how and when DAG runs are created. What does that mean? In cron, we just say in what days a task should schedule, or what days, or what how often the task should run. So that is what defined by cron. I think we already used cron in one of our codes that we written. Here we use them, by the way, we use them in the schedule parameter. Here we haven't used cron, but instead we use this one. This is a preset schedule. It is like a preset cron. This is not a cron, but there is a preset schedule. We can use @daily or we can use that @hourly for, so it executes every hour. Here we used @daily. There are preset schedules, but we can use cron. Okay, here it is. So this is how we schedule using cron. And we will now, I will explain about the the formatting of the cron, but for now, here it executes for every minute. So this is how cron works. We just schedule it for every minute or every hour or every day or every weekday. Or you can also, we can still go into deeper into the logic. Let's say every weekday for every minute. So we can also schedule, we can also repeat the task run in that logics. I think that's the only code we written the cron schedule. Here also we written the preset schedule, and here also it is preset. Okay, so that's the only preset that's the only cron schedule we used. So that is cron, but the maybe for some topics or for some situations, cron is not enough, and that is where timetable comes. Timetable is like advanced or modern technology than cron, where we can schedule the task with complex logics. All right, we can schedule the task according to the events that are occurring, or yeah, we can actually logically schedule the task. Let me try to get an example of that. Okay, So I asked ChatGPT to give an example where cron job cannot schedule the DAG in that way, but timetable can. Here it is. So the logic here is it should be scheduled on the first business day after month end at 9:30 a.m. But if month end falls on Friday, run Monday. If month end falls on Saturday or Sunday, run Monday, and skip public holidays. For this big logic, in order to, you know, schedule it using cron, it is not possible at all. That's why for us to be able to schedule the task with this complex logic, we can use timetable. And the code looks something like this. We define the holidays, we define the class first with the timetable, and we define the functions with the each business day, which are weekdays. Yeah, it looks something like this. I never worked with that, but I mean, basically, to be honest, cron scheduling is more than enough. We don't actually go to timetable unless we actually need it. We don't really want it. Who want this much of a complex logic, right? It is so rare situations where we need this logic, but cron job is good enough to schedule the tags. But we still need to know there is a topic called timetable, which is modern scheduler than cron job. That's why I just show you guys the example of timetable. Yes, so this cannot be scheduled in cron. Heading back to the PPT, the slide. Next we have Catchup. Catchup automatically create missed historical diagrams from start date up to the present. We already talked about it when I wrote the DAG. When I write the DAG on camera, I told you about the Catchup. Catchup and backfill are kind of similar things. Backfill manually triggering a DAG run for past dates independent of the scheduler. Okay, let's say the DAG is running and today's date is what? Today's date is 19. You can define a backfill saying you can define a backfill with the date time of 2025 fall, and you say today's 19. So you say, if you say 12, let's say 12. No, let's say 11. Okay. So if you say that backfill date time and you give a previous date or a past date, so what it happens is you manually trigger that to run and you know to run the tasks according to the schedule from the past, to catch up that. To be clear, I'm going to, so here we said backfill and gave the backfill a date, which is 11, and today's 19. What backfill does is it manually triggers the DAG to run immediately 8 more times, which includes one for 11th of December, one for 12th of December, one for 13th of December, one for 14, 15, 16, 17, 18. So we are actually manually triggering the DAG to run for the past dates independent of the scheduler. That's what it means. So it is something similar to Catchup, where Catchup just creates a like it says, where Catchup just creates some missed historical diagrams. Backfill is about manually triggering the diagrams for the past dates. They are kind of similar, but different. I hope you got the concept of backfill and catchup. Now let's switch to the next slide. Our next slide is about scheduling syntax words for the cron jobs. I mean, for the cron schedules. We already know this. We talked about these things, these preset schedules already, right? We already used them in 3 of our codes that we wrote today. We used daily for every single one of them. We can schedule using these preset schedules. Let's say @once, which makes the DAG run only once after it is unpaused, and there is @hourly, which makes the DAG run for once per every hour, and there is schedule @daily, which makes the DAG run once every day. So these are all preset schedules. They all we have all of this. So for the basic logic, we can just schedule the DAGs using the preset schedules. There is cron expressions where we can use logic to schedule these DAGs, and basically cron has 5 indexes. 5, is it 5? Yeah, 5 indexes. 0, 1, 2, 3, 4. I just counted it in index number values, so I started from 0 and not 1. So we have 0, 1, 2, 3, and 4 placeholders, and the first placeholder indicates the minute, and the second placeholder indicates the hour, and the third one, which is, no, I pronounced those index numbers wrong. So 0, the placeholder 0 indicates minute, placeholder 1 indicates hour, and the placeholder 2 indicates day of month, and placeholder 3 indicates month, and 4 indicates day of week. I think you're clear with that. And the field allowed values are here. For a minute, the value ranges from 0 to 59 minutes, because 1 hour have 59 minutes, so 0 to 59 minutes. And for hour, we have 0 to 23. And for day of month, we have 1 to 31, because we have 31 days per month. And we have, for month, it ranges from 1 to 12, because we have 12 months. And for the day of week, it ranges from 0 to 6. 0 indicates Sunday and 1 indicates Monday, and it goes vice versa. And 6 indicates Saturday. So 0 to 6, Sunday to Saturday. So that is index 4, by the way. We define the exact time, or exact month, or exact hour, or exact day, or exact day of the week when the task should execute. And the rest of these fields can be indicated with asterisks. Asterisk indicates every. Let me insert text here, text box, and say asterisk equals, oh, that's not asterisk. Asterisk equals every. Now let me give you an example first, so you'll understand. Let's say you want that task to run for every, no, no, okay. So you want a task to run, you want to run a DAG. You want a DAG to run every hour at let's say 30 minutes. Every hour, but 30 minutes. We can write that in this way. So we write that like set 30 minutes, right? So the minutes from 0 to 59, 30 minutes. And I fill the rest with stars, 1, 2, 3, and 4. That's how I write it. This is how you schedule it, and you say you use the parenthesis. Instead of writing here, I'm gonna write it in the code editor, so it will be clear for you guys to see. Right now I schedule it for every minute, by the way. So I'm going to take this out. I said, what was the question, by the way? So it has to execute every hour, but at 30 minutes. So I schedule it like this, 30, asterisk, 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 asterisk. Wait. It should have space in between, by the way. So 30 space, asterisk space, asterisk space, asterisk space, asterisk. This will tell Airflow to run this DAG for every 30 minutes. And asterisk, like I said, asterisk represents every. So it runs every hour, every day, every month, every weekday at 30 minutes. And let's say if you want to run a DAG every day, but at one let's say at 1 p.m. or yeah, 1 p.m. 1 p.m. should do. So now 1:30 p.m. Then what we do here is, instead of asterisk at the hour place, we use 13. We have to use the 24 hours clock. So 1 will be 13 here. So it runs. This DAG will schedule for every day, because day is asterisk. So every day, every month, every weekday at 1:30 p.m. That's how we schedule it. So that is how we can schedule the DAG using hours and minutes. And for the weekdays, if you just want to run the DAG every Monday, just every Monday, you can switch this to 1, because 0 represents Sunday. The next one, Monday, represents 1. So it runs. Now this is scheduled. This DAG will be scheduled for every Monday to run at 1:30 p.m. That's how we schedule it. That is one of the application. And talking about another application we have, we can specify multiple times, multiple hours or multiple minutes to schedule the DAG too. When I say that, what I mean is, so if you want to run that DAG at 1 p.m. and 1:30 p.m. and 1:30 a.m., you can do that too using a comma in between. We say 1 and a comma. This will schedule the DAG to run at 1:30 p.m. and 1:30 a.m. every Monday. So this is one of the application. You can use it for every parameter here. You can even use it for the weekday. If you want to run that same thing on Monday and Tuesday, you can just use comma and say 2. That will run the same DAG Monday and Tuesday at 1 a.m., 1:30 a.m. and 1:30 p.m. And another application. And the next application is range. Let me list all the applications first in the slide, so we'll have a track of it. I'm going to copy this text box again. Oh, this dot, this asterisk turned into a dot. It should be asterisk. Okay. So the first application we talked about is at exact time. We already saw how we can set the exact time. That's the first one. And the second application is multiple specified times, which is the comma we just saw. We can use comma to specify the multiple times, and then we have range that we are going to see. We can choose a range of times to run the same DAG, to schedule the same DAG. For example, let's say you want to schedule this DAG just on the weekdays, excluding the weekends, which includes Saturday and Sunday. So these DAGs should only be scheduled in Monday, Tuesday, Wednesday, Thursday, and Friday, only in weekdays. What you can do is, instead of just saying specified values like this, you can just say Monday is 1, Tuesday is 2, Wednesday is 3, Thursday is 4, Friday is 5. So you can just say 1, 2, 5. So this, here we specified the range. So it runs every day in that range, which means it runs on Monday, Tuesday, Wednesday, Thursday, and Friday, excluding the weekends, which are Saturday and Sunday. Those are 0 and 6, so they are excluded. Now this is scheduled to run on weekdays, to run on every weekdays. Weekends are excluded, and it runs on 1:30 a.m. and 1:30 p.m. So these are range works. Our next application is every n unit. Every n unit. How this works is, instead of defining an exact time, we can also say run this, schedule this DAG run for every minute, or for every hour, or for, no. We can schedule it for every 5 minutes, every 10 minutes, or every 1 hour, or every 2 hours. We can also do that. Let's say, let's clear all of these up. Get this back to the basic syntax. Okay. So let's say we want to schedule this DAG for every 5 minutes. What we can do here is, we keep the asterisk as is, and we use backslash and say, because it is for every 5 minutes, I'm going to say 5 here. So now this DAG will run for every 5 minutes, independent of date or time, or we're not going to define any specific time. It just runs for every 5 minutes. Same apply for the other placeholders too. If you want to run that for every 5 hours or every 10 hours, you can just put slash and say 10. So this will run for every 10 hours, once for every 10 hours. And then we have days, the same thing. This is also the same thing. So in this way, we can combine the logic together and get the output scheduler logic of whatever kind we want. So that's why I said cron scheduling is good enough. We don't actually want to go to timetable. Timetable is quite complex. That is for the complex logics. And we saw all the applications of cron schedules, but now let's put that into practice. I'm going to demonstrate how these schedules work for every single application. Don't worry, I'm not going to run the DAX now, I'm just going to show you the schedules. First, let's see an example for, let's say, every 2 days. So that is our first application, which is at exact time, right? So that is our first application. We're going to schedule it at exact time. Just this one. Now save it, head to the UI, DAX. Yep, it is scheduled for every 2 days. Sorry, my bad. We haven't scheduled it for every 2 days. We scheduled it for the second day of every month. That is what we did here, right? So that is why we call it exact time. So we scheduled it for the second day of every month, which will be the next month, because today is December 19th. The next second day of month will be next month, which is January. That is why the next one is scheduled at 2026, January 2nd. So that is a demonstration for the first application, and for the second application, we have multiple specified times. So we have that and this. Back to this one. Now we specify. Now we already specified second day of every month, but we're going to add first day of every month too. So it executes, it schedules for first of every month and second of every month. Now when we save it and head back to the UI, there you go. Now it shows the next run as 1st of January because it runs for every first day and the second day of every month. So the next run will be 1. And we can actually see the cron schedule that we used right here under the schedule. We can see the logic that we used for that. And even for this one, even when we use the preset ones, it's still we can still see the cron schedule format. Whereas in this, as in this DAC file, which is bash operator demo, let me show you that. Bash demo, here, you see that? We actually used preset schedule, which is @daily, but here it automatically converted that into a cron schedule. It says 0 hours, 0 minutes, at 0 hours, 0 minutes, but at every day. That is how the modern preset, not the modern one, the preset schedules work. Now we have the demonstration for the second application too, right? Now we have the range here. Let's say I'm going to give the range as today is 19, right? So I'm going to give the range as 16 to 22. 16 from day 16 to 22 of the month of every month. So if we save this, refresh this, there you go. You can see that because today is 19 and 19 is already done, the next run will be on 20th, which is tomorrow. So because we define a range of times here, that's how the range works. And for every minute or every 5 minutes, let's do it for every minute. So we will know how it works. Every minute. Okay, save it. Go back to the UI, refresh it. No, sorry. Did I show this? Oh, my bad. I have to show UI demo once. Yeah. So now it is scheduled for every minute. The next schedule is at 28. Now the time is 27 because it is 7 p.m. So the next run is at 8 p.m. It already started running because it already passed the minute. Okay, that's how these cron schedules work. I think you got it, because I mean I also want to show you the demonstration of every one of them, so that's why I did it. So I'm going to send you the PPT as well. Like I said, I'm going to give the link for the GitHub, and that GitHub will also have this PPT uploaded. So you can use this page for the cron scheduling. This is so useful, I guess. But for now, let me stop that tag. It's just extra computation. I'm gonna pause it. Okay, that's how they work. Now, let's head to the next topic. Next topic is task group and dynamic task. First, let's talk about task group. A task group is nothing but a group of tasks. We can group the tasks to, have more control over them, control over the dependency. For example, for now, we only saw linear dependencies, right? Let's take an example first. Let me go to one of our UI demo. Okay, here we just talked about linear dependency. So this block alone this task, transform data, is only dependent on this task alone, and load data is only dependent on this task alone. What if you want to create a condition where one task, let's say you have 3 tasks. Let's say you have 3 tasks. Okay. This is C and this is A and this is B. And your condition is task C should be executed only if both these tasks execute, and they should execute at the same time. What if you have that kind of logic? You cannot do that with any of these, right? But what can you do is you can create a task group. You can group these 2 tasks into a task group, and it looks something like this, the relation. So these 2 tasks will group to each other, and only if these 2 tasks executed successfully without any error, only then task C starts executing. That is how task group works. Now I do have a demonstration. I'm going to write a code. I'll try to write it quick because it's already I think the session is already extended more than 5 hours or 4 hours, so I have to make it quick. Back to the VS Code editor. Here I'll create a DAC file again. a .py file, name it capitals group demo.py. Let's import the modules that we need here. First, of course, we need the decorators for the modern API, which is Taskflow API. Airflow.sdk, import DAG and task. And we also need date time for the scheduling from date time. Import date time. Now we import task group, the module task group, to group the tasks from airflow.utils dot task dot group import capital T ASK task, capital G ROUP task group. Now we imported the module task group. Let's define the DAG first. With the decorator, we define it as @DAG, open parenthesis, we define the start date as usual. Start date would be date time of 2025. Well, today's okay 18. I'm gonna say 18, comma. Catchup equals false, comma. Schedule equals none. Let's say none. So you don't execute unless and until I trigger it manually. So if I say schedule is none, I don't even need to define catchup as false because it doesn't matter, right? Because I haven't scheduled it. I just say none. So it only triggers when I manually trigger it. You don't trigger on schedule. So schedule is none. Then say define the DAG task group example. Now for the task, I'm going to create the task group now. To create a task group, this is the syntax. We say with task group of extract tasks as extract now our first task in our task group, which will be def extract users. This is just an example, by the way. This is just to show how task groups work. Now this is not an application for any of that. I'm just going to print, that's it. I'm not going to use any coding here. I'm just going to print static strings here. Print, and static string will be let's say extracting user. I think I forgot to declare it as task using task decorator. That okay, and let's define our second task in the same group. F extract orders. The same way, I'm just going to print a static syntax, a static string here for every task. Extracting orders. And we have these two tasks. We have to write those task definition IDs here at the end, which is extract users and extract orders. Yes. Extract underscore orders. Okay. That is the task group. Now let's define the separate task, which is independent with this task group, which is not part of this task group, but still it is dependent on this task group. Only when both the tasks in this task group execute successfully, only then it goes to the next task, which we are going to write now. Create task say load of and print loading data. Then at the end we define the dependency here, extract, and after that there comes the load. Now you see what I'm doing here, right? I'm just taking a scenario where, let's say you're working with a project and you want a pipeline where you extract the users and the orders, and only then you have to load the data. You want to load the data. You have to do both of them parallelly, and only then, if both got extracted, only then you want to load the data somewhere. In that scenario, we use a task group like this. I created a task group with two tasks, one for extracting users and the other one for extracting orders, and I defined those two tasks at the end. I mean, I defined it and then we have to write this at the end, by the way. Okay, we have these two tasks. Only this whole task group executed successfully, only then the next task, which is load, will start executing. Now let's see this. Let me save it. So now let's see this on the UI. Let's open Airflow UI. Back. I did not add any tag to it, so it is kind of hard to find the tag. Just refresh it. Okay, it says 86 tags, which should be parsed already then. Task group example. Now I have to search it with the name because I haven't defined any tags. Task group example. Okay, I don't find any task group example. So it is still parsing, I think. So I cannot find it. In the meantime, I'm going to add the tags as well. Why not, right? Tags. I'm going to copy the same tags maybe. No, that's fine. tags equals. I'm going to say group. That'll be easier for us to group tags. Group tasks. That should do. One tag is just fine. Now let's head back to the UI. Refresh. There is error. What is the error? Okay, the error here is this is supposed to be task underscore group and not task dot group. I hope that's the only error I made. So that's task underscore group. Okay, I fixed it and saved it. Now let's refresh that again. Okay, we do have another error, I think. No, it is not patched yet. Actually, there is one more error I have to fix, which is this one. I forgot to assign the task definition to a variable or component first before I define the dependency here. I have to do this first. I'm going to assign the task definition because here this definition is written in the modern API, which is the TaskFlow API. But here, defining this dependency is not modern API. That's classic API. In order to blend in, we have to first assign the task function to an actual component or class, and then we can define the definition, the dependency definition, in this way. And also, I forgot to copy paste this at the end. The DAG definition. We have to copy paste it at the end. I think now it should work. Let's head back. Retry. There you go. Now the error is solved. What was our DAG? Our DAG is group tasks. Group tasks. Okay, there it is. At first, let me go back. This is how the group task, the task group looks like in the tree view. You can just extend the task group and you'll see the tasks in the task group. See that? And in the graph view, these are it looks like. At first, it looks like this. If you extend, if you click on the +2 tasks, these are how it looks. You see the diagram, you see the the relation. So these two have a common node, and if any of these two tasks fail, it will not execute the load one. That's how it works. So these are how the group tasks work. Now let me execute it and show you how it works. See that? So they're both, if you actually took a close look at that, when I execute it, I'm going to trigger that again just to show you. You see that? First, these two will execute before load executes. Actually, at the first time it was so clear, but now they look like all of them are executed at the same time, but they're not. It makes sure to execute these two tasks first before going to load. And each task in the task group have its separate logs. Just the group is just to combine them, but the logs are still separate. Now for the same thing, I'm going to wantedly ingest an error in an exception for one of these tasks. Let's say for extract orders, and see what happens now. I'm going to pick the error from the test that we used previously, the rise exception. And I'm going to paste it in our extract orders task right here. Now save it, head back, reload, check the code. Yep, it does have the exception. Now, when we trigger this, the first one will execute, which is extract users. But the second one, raise an exception, which means it will not let the other task execute because upstream failed. You see that? That's how task groups work. Okay, we are done with this demonstration. Now let's head to our slides. No, I don't have a slide for that. I forgot. Okay, we're done with that demonstration. Now let's talk about dynamic task. Talking about dynamic tasks, they are so useful in some situations where you have two tasks dependent on each other and you don't know, I mean, the values from task one are returned as arguments to task 2, but you don't know how many values or how many files the task 1 will return. And according to that, task 2 should, adopt. So in that case, we can use dynamic task. To be clear, let's say this is task A and we have task B, right? So this is task A and task B. So we have task A and task B. Whatever the value task A returns will be returned as arguments to task B. Just like in the table that we used, where I cannot show that to you because if I want to show that this this diagram I just drawn will be gone. So I cannot show that code. Yeah, if task A returns a value which will be returned as an argument for task B, and if you're not clear how many values or files task A will return, and task B should adopt accordingly, right? If task A returns multiple files and you don't know the count of files, task B should adopt accordingly, right? Let's say task B returns 3 files. Then we need 3 separate B tasks, right? We need 3 separate B tasks to run. Yes, and you don't have a particular number of how many values or how many files A is going to return. If it returns 4, all of a sudden it starts returning 4. It has to scale automatically to 4 tasks. In that situations where you don't know what one task returns, the number of returns that one task do, the upstream task, and you want to make the downstream task adopt accordingly, you use dynamic task. I think it is harder to explain it with pictures or whatever, but now I'm going to show you a demonstration for that to make it more easier for you to understand it. So let's go ahead and write another DAG file for dynamic task. Let's create another Python file and say dynamic dynamic task.py. There is, and let's import the modules that we need. We import from Airflow, we import of course the DAG and task decorator, and then from date time import date time. Now we don't import anything special, any special module for dynamic task like as in group task, where we import a task group. We don't import anything special in dynamic task. This is just fine. Now let's define our tag. DAG, open parenthesis, start date equals date time as 2025, comma 12, comma 18. Just like as in task group, we're not going to schedule it. So we're going to do schedule equals none. So we're not scheduling it. It only runs when we manually trigger it. And for the DAG definition, define dynamic task example. We don't do anything different at the beginning while we define the task. What actually changes is at the end, after we define all the tasks, at the end we do something that changes everything, that makes it dynamic task. So we define the task now with the decorator @task get files. Let's say get files, return, and we return, say we return list of 3. This is just a list, but in real world it returns files. Here we're just returning a list of strings. Files dot, say files file1 dot csv, comma file2 dot csv, comma file3 dot file3.csv. That's it for the task 1. And for the task 2, it takes the returned value from the task 1 and it returns the values as arguments into that task and then process it. Task define, say process file name. Right now we're just going to design the task so it only process one file at a time. This is the argument we're passing here. And then print. I'm going to use f strings here. F strings processing. Say flower brackets. file name. So this prints which file this task is processing. I think that is good enough. Now we have task 1 and task 2 defined. Now we do the same thing that we did in the task group. Now we're going to assign the task definition to a variable. Files equals get files of and process file dot expand. This is where the magic happens. This is what makes the task dynamic. Expand file name equals files, and then at the end we have to paste this, the DAG definition. So here we created the two tasks, we created the DAG, we created the two tasks as usual, and next we assign the get files to files variable, and then at the end again here we used process file dot expand of. So this particular task expands according to the files that this task is returning. So that's how we frame the relation here. Now, because we use expand here, no matter the count of files that the get files task returns, process file will expand accordingly and process them one by one with as different tasks, as separate tasks. So this is dynamic. This is called dynamic because we are not defining a static amount of tasks. We are not defining 2 or 3 tasks. We are defining a dynamic task which can expand according to the upstream task return files. That's why it is named as dynamic task. Now we save it, head back to the UI. If this get passed, this should change to 88 tags. To make it more easier for us, I'm going to add a tag for this too. Tags equals list. I'm going to say dynamic task demo. A big tag, that's fine. So I'm going to use that. Now we'll let Airflow process it, parse it. Okay, it took a while. Now I can see the number change to 88, sorry. Let's search for our tag, which is dynamic task demo. There it is. Okay, click on it. Right now, process file is 0. Right now, it doesn't show any extra tasks, right? Yeah. Doesn't show any extra tasks. Now, when I trigger it, this is running. Now, this will return 3 files, theoretically 3 files. So to actually adopt to that 3 files, this task will expand into 3 different separate tasks, and they all have their own index. If you see here, when I click on this one, you see that? So it is divided into 3 different tasks, just task instances. It looks like this in tree view. And yes, that's how it works. Yep, that's how it works. I think there's nothing else to see in the UI with the dynamic task. I'm just checking if there is anything different to check on. Okay, so every single instance of that task, because we have 3 instances for one single task, which is process file. For every single instance, it has its own dedicated logs. So this is for the one of the partition of that dynamic task. This is for the second. So if any of that instance fail, we can see it. So if one of the instance fail, it shows here. If one fails, it says it says that one failed. But all 3 are successful, so it says successful. I think that's it. That's it with the dynamic task, and that is our last topic of this masterclass. With that, we are officially done with the masterclass, Airflow masterclass. I hope you like the video. If you like the video, don't forget to subscribe and share to your friends who actually want to watch or learn Airflow. And I think you already realized I started posting quizzes every single day. Now, from now on, I'm also going to blend in few of the Airflow questions in that quizzes. So you'll go according to that and keep up with the concepts. And that's it. That's it for the video. Hope you like it. Adios.